Check, check, check.
You choose what you want and you like the most, and boom.
Check, check, check. Yeah, கேக்குது. Check, check, check. Yeah, okay. Okay. Hi. Hello. Hi. Sorry, கொஞ்சம் லேட் ஆயிடுச்சு because was fasting break பண்ணிட்டு ப்ரேயர் முடிச்சுட்டு திரும்ப வந்து உட்காரக்கும் டைம் ஆயிடுச்சு. But I'm here. Okay. Yes. Okay, so as usual நம்ம கிளாஸ் எப்படி ஆரம்பிக்குமோ as usual let's start with your doubts. Hi Merlin. Hi Asina. Hi Safura. Ask me anything because see ஒன்று உங்களுக்கு டைம் கம்மியாக இருக்குது. ஸோ இஃப் யூ வாண்ட் டு ட்ரை சம்திங் எல்ஸ் புதுசானா you don't have anyone to ask me because I've been in the same exact situation as yours on the time la. Okay. So just ask me anything because see here I had a few seniors of my own. Okay, they are like school seniors தான். அவங்க வந்து இப்போ என் காலேஜில் படிச்சுட்டு இருக்காங்க. I used to talk to them about all this stuff, what am I supposed to do and all. I have like என் காலேஜ் 2 பேர், ஸ்டான்லியில் சில பேர், I have one in Jipmer. I used to ask him before he wrote his NEET examination. I used to ask him. So yeah, இந்த மாதிரி they help me a lot. Honestly இந்த மாதிரி பண்ணு அப்படி பண்ணு எல்லாம். இப்போ என் சீனியர் வந்து இப்போது நான் நீட் எக்ஸாம் எழுதுகிற அன்னைக்கு கூட he called me and like இந்த மாதிரி பண்ணு, don't do this, don't do that and all. It all helped. Okay, so that's why if you are not aware of what it is, At least I could help. Okay, is magnitude of a physical quantity constant in any other system of units? Magnitude is denoted by number. Okay, it's fine. See mm, the say I'm taking force. Okay, force. Okay, force வந்து இப்போ நான் நியூட்டன்ல இருந்து டைனா மாத்துறேன். ஓகே ஓகே ஸோ அப்போ வந்து யூனிட் கன்வர்ஷன் ஆகும்போது the magnitude changes. Okay, obviously. So ரெண்டு சிஸ்டம் ஆஃப் யூனிட்ஸில் the magnitude changes. But the core thing is இருக்கு இல்லையா, the amount of force I applied, you can tell it in meters, newtons சொல்லலாம், டைனில் சொல்லலாம், or distance travel பண்ணுது, you say it in meters or say it in centimeters, the thing it's constant. Okay, we are converting it because we are having a new system of unit in that. Fine, அதான் வந்து the formula, it goes like n1 u1 equals to n2 u2. அதாவது your numerical value and the unit system of unit multiply பண்ணும்போது should be equal to the numerical value and the system of unit which you are taking for consideration. Okay, so like when you have two system of units, say meter SI and CGS. Okay, அதில் வந்து SI systemல வந்து you're having a unit. Okay, meter. CGSல you're having centimeter. Okay, இப்போ இந்த ரெண்டு யூனிட்க்கும் ரிலேஷன்ஷிப் சம்திங் இஸ் there. Okay, அதுக்கும் இதுக்கும் when you try to equate them, அப்போ your n, say I'm traveling 100 meters, 100 in meters should be equal to my x distance in centimeters. Centimeter is nothing but 10 power minus 2 meters, correct? So it will be 10,000 centimeters. Okay, fine. The value stays same because the unit system of unit is changed ஆனதால the numerical value வந்து decimal point add ஆகலாம், subtract ஆகலாம், add ஆகலாம் இல்லை குறையலாம். Okay, hi. Okay, ask me queries, guys. This is not your preparation area, but still, okay, I'll try to solve as many questions as possible, whether it may be bio or chemistry if I remember, but physics, yeah, obviously. How has been your preparation so far? இப்போ வரைக்கும் you have like March இந்த மாதம் and then April, you have 2 months. எல்லாத்தோட ப்ரிப்ரேஷன் எப்படி போயிட்டு இருக்கு? Oh, NEET 2027 aspirant. Okay, nice. Nice. 2027. You're in 11th standard. 11th standard subject பார்க்க வந்திருக்கீங்க. Okay, fine. Aspirant. So அவ்வளோதான். Yeah, no one has any other queries about your NEET preparation. Come on, guys, test me with few questions. Is it good to completely skip a chapter in chemistry for NEET? Okay, is it good to skip a chapter completely for NEET? It depends on what chapter you skip. Okay, you can't skip anything in organic. You can't skip a lot in inorganic. You can't skip in physical as well. Well, you could skip a few in physical. And organic, it's, if you ask me if it's good na no. Okay, it's not, it won't, it can't be called as a good decision when you skip chapters. Okay, because the question paper is constructed over all these chapters. Okay, so whatever chapters are present எல்லாத்துலேருந்தே ஒரு கொஷின் வரும் ஆர் அந்த சாப்டரோட கான்செப்ட் வில் கம் இன் சம் ஆஃப் த கொஷின். ஸோ it's designed on the basis, on the idea that everything should be covered. Okay, every chapter should be included in the paper. Okay, so when you skip a chapter, you would probably skip a few questions. Okay, 2 questions. Yeah, but it's not advisable. Okay, vana. Now only I'm starting my preparation. Merlin, all the best. Okay, all the very best. How do you structure your time during NEET preparation? Are you 9th grade? Okay. Equilibrium, CS ionic equilibrium. Yeah, அந்த சாப்டர் வந்து okay, we have questions. Thank you. How did you structure your time during my NEET preparation? Okay, during the last 2 months, what I did was, last 1 month, what I did in the entire April month சொல்றேன். Morning we used to have one grand test. Okay, morning காலைல எஞ்சி உடனே 9 மணிக்கு they will have test. 12 o'clock it will go over 3 hours 20 minutes எங்களுக்கு டைம் இருந்துச்சு. ஆனால் 3 hours தான் கொடுத்தாங்க. அண்ட் அது முடிச்சதுக்கப்புறம் எரர் கரெக்ஷன் 1 hour 12 to 1 something we have lunch. அதுக்கப்புறம் afternoon we another test. Okay, எரர் கரெக்ஷன் சும்மா மேலாப்பில் பார்த்துட்டு சும்மா கொஞ்சம் படிச்சுட்டு, பிகாஸ் வாட் எவர் மிஸ்டேக் ரொம்ப அப்பட்டமாக தெரியும்ல நமக்கு இந்த மிஸ்டேக் பண்ணியிருக்கோன்ட்டு என் கான்செப்ட் தெரியாமல் அந்த கொஷின்ஸ் எல்லாம் பார்த்துட்டு, and then I'll move to have lunch, and then 2 o'clock again another exam, proper neat timing, 2 o'clock to 5 o'clock second paper. இது முடிச்சுட்டு I'll take a break for 1 hour. 6 o'clock வருவேன். I'll solve the entire paper again. Whatever mistake I did, whatever I thought I left as choice questions, everything will be solved, both the papers, before 8 o'clock or 9 o'clock. And 9 to 11 I'll study in my school block, and then hostel வந்து 11 to 12:30 1 வரைக்கும் படிப்பேன், and then I'll sleep. Okay, that was my schedule last. Equilibrium chapter la ionic equilibrium, if you wanted proper explanation na videos are available in this chapter. Okay, it's important na chapter படிச்சுக்கோங்க ionic equilibrium. Okay, hi bro, recent days I'm finding a lot of question prediction videos, அதெல்லாம் follow பண்ணலாமா? See, you can't predict questions. Okay, no one can predict questions. Okay, நீங்கள் 2025 ஓட ப்ரெடிக்ஷன் வீடியோஸ் எல்லாம் பார்த்துருந்தீங்கன்னா அதுக்கும் பேப்பருக்கும் சம்மந்தமே இருந்திருக்காது. Okay, they make an entirely new question. They like literally construct something which doesn't exist. Okay, and the question is like super new. அதனால தான் வந்து we are PYQ சால்வ் பண்ணுங்க சொல்கிறோம். ஏன்னா அந்த கொஷின் வந்து ஓகே கான்செப்ட் இருக்கும், ஆனால் சம்டைம்ஸ் அதை அப்ளை பண்ணுற விதம் வேறு மாதிரி இருக்கலாம். ஓகே, இந்த மாதிரி கொஷின்ஸ் எல்லாம் கேட்கலாம், நம்மளால் ஆன்சர் பண்ண முடியும், பட் அந்த மாதிரி கொஷின்ஸ் யூ wouldn't have seen anywhere. ஓகே, அந்த மாதிரி கொஷின்ஸ் தான் மோஸ்ட் ப்ராப்ளி வரும். கொஷின்ஸ் அப்படியே ரிப்பீட்லாம் ஆகாது. வாட் will repeatனா concepts of that question. So இந்த கான்செப்ட் இந்த கொஷின் வரும், அந்த கான்செப்ட் கொஷின் வரும், those things will repeat. Okay, so is it advisable to watch everything? Probably practice on your own. ஏன்னா அது it's not advisable to have a look at all those videos. எல்லாமே பார்க்கணும் அவசியம் இல்லை, பட் வாட்ச் a few, because கான்செப்ட்ஸ் வந்து யூ வில் கெட் கிளாரிட்டி. இந்த மாதிரி மாடல்லாம் கொஷின் வரலாம் அப்படின்ட்டு இஃப் யூ ஹேவன்ட் ப்ரிப்பேர்ட் அந்த செப்பரேட் செட் ஆஃப் கொஷின்ஸ், அண்ட் இஃப் சம்மன் டீச்சர்ஸ் யூ ஆன் யூடியூப்னா இட் வில் பி ஹெல்ப்ஃபுல். I'm fine. Okay, முடிஞ்சு. Bro, can you please tell what did you do in the early phase of your preparation? In the early phase of my preparation, it didn't go well. Okay, I struggled a lot. நான் வந்து 11th end வரைக்கும் I was getting around 450 something, 450, 460 average. Okay, average. I used to get like same mark எல்லா எக்ஸாம்லேயும். And then yeah, அப்போ இருந்தே வந்து I had little இல்லை கொஞ்சம் நிறையாவே problems with chemistry. Okay, I didn't understand what it was about. Thank you for my teachers for helping me out. 12th அது உட்காந்து எனக்கு திரும்பி சொல்லி கொடுத்தாங்க நிறையா கெமிஸ்ட்ரி ஃபேக்கல்ட்டிஸ். ஸோ யா, அப்போ ஆனால் ஸ்டார்டிங்லேருந்தே வந்து ஐ யூஸ் டு ஹேவ் திஸ் எரர் கரெக்ஷன் நோட் வேர் என்னோட மிஸ்டேக்ஸ் எல்லாம் வந்து அதில் எழுதி வச்சுப்பேன். ஐ வில் கரெக்ட் வாட் எவர் மிஸ்டேக்ஸ் ஐ டூ, எதெல்லாம் ஸ்கிப் பண்ணியிருக்கேன் கொஷின்ஸ் அதெல்லாம் வந்து எழுதி வச்சுப்பேன். ஸோ யா, தட் வாஸ் கோயிங் ஆன் லைக் ஆல் த டைம். Can we prioritize research out of 4 to unmaster it to get into GMC? No, please don't do that, because okay, fine, when you have say it's better you study everything, but if you have some sort of reservation and if you weren't able to concentrate on everything, I think it might help focusing on bio and chemistry more than physics. Okay, SB 139 நீங்கள் வந்து 2026 இந்த வருஷம் எழுத போகிறீங்களா நீட், இல்லை அடுத்த வருஷம் எழுத போகிறீங்களா? ரொம்ப குழப்பம். லேண்ட் மார்க் டெஸ்ட்டில் 450 எடுக்கிறேன். இட்ஸ் ஃபைன் ப்ரோ. ஏன்னா என்னோட ஃபர்ஸ்ட் மார்க் டெஸ்ட், ஓகே, என்னோட ஸ்கோர் வந்து 400. ஓகே, லிட்டில் 400. இது வந்து இந்த மாதம் நினச்சா 2024 ஜான்வரி. ஓகே, ஜான்வரியில் 2024 I was writing my first ever grand test. அதில் I got 450 marks, 400 marks. அதுக்கப்புறம் சேம், correct your mistakes, try to manage your time better, practice more questions. அந்த 3 hours டைம் எப்படி ஸ்ட்ரெஸ் இல்லாமல் மேனேஜ் பண்ண முடியுமோ அதை நீங்கள் டெவலப் பண்ணிட்டீங்கன்னா இல் பி ஈஸி. ஓகே, டோன்ட் வரி. ஆம்ப்ரோஸ் மர்லின், யா, டிசம்பருக்கு முன்னாடியே முடிச்சிருங்க. டிசம்பருக்கு முன்னாடியே ட்ரை அக்டோபர். ஓகே, அதுக்கப்புறம் வாட் யூ டூ, ரிவைஸ் the entire thing again and again. Okay, so like you start with 2020 டிசம்பரில் இல்லை அக்டோபர் வரைக்கும் நீங்கள் என்டையர் 11th and 12th முடிச்சுக்கிறீங்க. ஓகே, அண்ட் தென் அகெயின் 11th ஸ்டார்டிங்லேருந்து யூ கோ ஆன் 12th, அப்புறம் and then 11th and 12th, அப்புறம் யூனிட் டெஸ்ட், and then பார்ட் டெஸ்ட், கிராண்ட் டெஸ்ட், அந்த மாதிரி இஃப் யூ கோ ஆன் ப்ரோக்ரெசிவ்லி, பிகாஸ் ஒரு வாட்டி ப்ராப்பராக படிக்கிறதுல யூ வில் நாட் பி ஏபிள் டு ரிட்டைன் ஸ்டஃப். ஓகே, நிறைய வாட்டி ரிவைஸ் பண்ணும் ஃபார் த சேக் ஆஃப் ரிவிஷன். இந்த மாதிரி ஸ்கெடியூல்லாம் எல்லா இன்ஸ்டியூட்லையும் பண்ணி வச்சுருப்பாங்க. they have சீக்கிரமாக முடிச்சுட்டு அகெயின் சேம் திங் will be repeat again twice or thrice sometimes. ஓகே, நைட்லாம் தூங்கவே முடியல ப்ரோ. மிட் நைட்லேருந்து ஃபிசிக்ஸ் சால்வ் பண்ணுறேன். ஓகே ப்ரோ, SB 139 இட்ஸ் ஆக்சுவலி குட். மிட் நைட்டில் ஃபிசிக்ஸ் சால்வ் பண்ணுறது தூக்கம் வராதான். ஓகே, சடனாக மோட்டிவேஷன் ஸ்பீக்கர் மாதிரி பேசணும்னு நினைக்காதீங்க. தூக்கம் வராதான், எனக்கும் வரல தான். ஓகே, இட்ஸ் பார்ட் ஆஃப் யுவர் ப்ரிப்ரேஷன், யுவர் ஜேர்னி. ஓகே, நீட்டில் அப்படி தான் இருக்கும். ரொம்ப ஸ்ட்ரெஸ் எடுத்துக்காதீங்க. ஓகே, இது சொல்ல ஈஸியாக இருக்கலாம், பட் உங்களுக்கு தான் தெரியும் எவ்வளோ கஷ்டன்றது. பட் ட்ரை டு நாட் பி ஸோ ஹார்ஷ் ஆன் யூர் செல்ஃப். லைக் என்னால் முடியவே முடியாது அந்த மாதிரிலாம் இருக்காதீங்க. இட்ஸ் ஸ்டில் பாசிபிள், டோன்ட் வரி. அண்ட் ஃபிசிக்ஸ் சால்வ் பண்ணுறது இட்ஸ் ஆக்சுவலி குட் திங். ஓகே, ட்ரை சால்விங் ரெகுலர்லி. அண்ட் அதுக்கு முன்னாடி ஹாவ் குட் ஸ்லீப். ஓகே, sound sleep வச்சுக்கோங்க some 6 or 7 hours கிட்ட. Okay, which இருந்தா I did this mistake startingல. I used to study all night and then morning examல போய் I'll be blank. Okay, but I know the answer to those questions. Okay, ஆனால் எக்ஸாமில் வந்து I was not able to reciprocate the same amount of stuff which I had practiced. Okay, அதனால I was not able to score much. And then my friend told ஒரு வாட்டி நல்லா தூங்கி பாருன்ட்டு. இட் ஆக்சுவலி ஒர்க். நல்லா தூங்கினேன். அதுக்கப்புறம் எக்ஸாமில் மார்க்ஸ் எல்லாம் கொஞ்சம் கொஞ்சம் இம்ப்ரூவ் ஆரம்பிச்சிது. ஸோ டோன்ட் சாக்ரிஃபைஸ் யூர் ஸ்லீப். ஓகே, மிட் நைட்டில் என்ச்சு பண்ணுறீங்க, ஓகே, பட் கரெக்டாக தூங்கிக்கோங்க. ஐ எம் ஏபிள் டு ரைட் ஒன்லி 20 ஃபுல் மார்க் வித் ப்ராப்பர் அனலைசிஸ். யா, இட்ஸ் ஃபைன், இட்ஸ் சஃபிஷியன்ட். ஓகே, அது போதும். ஆனால் ப்ராப்பராக அனலைஸ் பண்ணுறீங்களான்னு பார்த்துக்கோங்க. I wrote around 60 or 60, 70, 75 to 80 grand test எழுதிருப்பேன். 80 full syllabus test. Okay, daily 2 and then அப்பப்போ occasionally 3 and on my own I wrote some 15-20. So but 20ல தான் நிற்கணும்னா அவசியம் இல்லை. உங்களுக்கு டைம் 10ல் ப்ராப்பராக 3 hours உட்காந்து இவ்வளோ தான் என்னால் சால்வ் பண்ண முடியுதுன்னா இட்ஸ் ஃபைன். But if you were able to do more na, try to solve at least 50 or 60 mock tests. ஏன்னா நீங்கள் எவ்வளோக்கு எவ்வளோ அந்த 3 hours டைமிங்க்கு அடாப்ட் ஆகிறீங்களோ அவ்வளோக்கு எவ்வளோ இட் will be helpful. என்டி ரிலீஸ் சாம்பிள் கொஷின் பேப்பர்னா ஓகே, I will have a look into that. Okay, I didn't. Sir, dropper can see this crash course. It will useful or collapse. For a doubt, can I see or recall what I read and solve? Yeah. Or 5 minutes I'll start the class. Okay, it's 7:05 already. I'll start the class கொஞ்ச நேரத்துல. Okay, you can watch this for sure. And read reset, try to solve more mock tests. And SB 139 தயவு செஞ்சு நல்லா தூங்குங்க பிகாஸ் ரொம்ப ரொம்ப இம்பார்ட்டண்ட். தருண் விஷ்ணு என்டிஏ சாம்பிள் கொஷின் பேப்பர் அது நான் பார்த்தேன், வந்திருக்குதான்னு நினைக்கிறேன். ஐ டோன்ட் நோ, ஐ செக் அண்ட் டெல் யூ. இந்த மாதிரி இருந்துச்சுன்னா ஐ சால்வ் இட் லைவா. ஓகே, ஓ என்டி ஆப்பில் பார்க்கணுமா? ஓகே ஃபைன் ஃபைன், I'll check it out. Okay, and if you have any other doubts, wait till the end of the session. Session endல வந்து I'll solve everything. Okay, all right, நிறைய பேசியாச்சு, கிளாஸ் ஆரம்பிக்கலாம். ஓகே, ஓகே. apparently என்னோட ஸ்டார்ட் கிளாஸ். ஓகே, என்னோட போஸ்டிங்லேருந்து there's ஐஏ ஆஃப்டல் நாலேஜ் ஐஏ மேம், she's been calling me PG ma'am. Fine guys, this is me Rehan from Madras Medical College, second year MBBS, here to take physics in SNG. This is our Vidamuyarchi 2.0 team. Beautiful team. All these people every day live at 6 or 6:30 அந்த மாதிரி. இந்த டைமில் you'll have people to take classes for you. Done. And then yeah. And இன்னைக்கு சரணனாக்கு ஃபைனல் இயர் எக்ஸாம். ஓகே, ஃபர்ஸ்ட் எக்ஸாம் முடிஞ்சிச்சு, மெடிசன் ஃபர்ஸ்ட் பேப்பர். எல்லோரும் முடிஞ்சால் போய் விஷ் பண்ணுங்கள் அடுத்த எக்ஸாமுக்கு. There is a test series in our SNG app develop பண்ணக்கு it took some time. I took physics question papers இந்த ஆப்பில். நான் நல்ல ஸ்டாண்டர்டாக தான் கொஷின் பேப்பர்ஸ் எடுத்திருக்கேன். ஸோ if you want to solve போய் check it out. Okay, all right, this is fluid mechanics for you guys. ஓகே, சேட்டில் கொஞ்சம் எனர்ஜி இப்போ எனக்கு வேணும். இவ்வளோ நேரம் பேசியாச்சு. இப்போ I need some energy in chat because I am deprived of it. நான் வந்து கால்லேருந்து I didn't have anything ப்ராப்பராக. Come on guys. தேங்க்யூ ஸோ மச். டிஃபிகல்ட்டாக இருக்கா? எது டிஃபிகல்ட்டாக இருக்கு? என்டிஎஸ் சாம்பிள் பேப்பர் இஸ் டிஃபிகல்ட். ஓகே, டிஃபிகல்ட். ஓகே, ஐ செக் இப்போவே பிகாஸ் டிஃபிகல்ட்டாக இருக்கா? என்டிஏ சாம்பிள் பேப்பர் ஹேஷ்டாக் சிபிஎம்பி கிராக் பண்ணுறோம், மாஸ் பண்ணுறோம். மலின் 1 minute சைட் லோட் ஆகிட்டு இருக்கு. கொஸ்டின் பேப்பர் பார்த்து சொல்கிறேன். தேங்க்யூ ஸோ மச் ஃபார் தி எனர்ஜி கைஸ். தேங்க்யூ ஸோ மச். ஓ, இது என் டைம்லேயே இருந்துச்சு. இந்த மாதிரியெல்லாம் வந்து இட் வாஸ் தேர் பிஃபோர் ஒன்லி. முன்னாடியே இதெல்லாம் இருந்துச்சு. தே ஹாவ் மார்க் டெஸ்ட் இன் தேர் ஆப், இன் தேர் வெப்சைட். ஓகே, ஸோ இஃப் யூ கோ டு த வெப்சைட் அண்ட் மார்க் டெஸ்ட்னு கொடுத்தீங்கன்னா அதில் வந்து நீட் கொடுத்துட்டு பேப்பர் ஃபிசிக்ஸ் ஓகே. கைஸ், இதெல்லாம் ரொம்ப சிம்பிள் கொஷின். இந்த ப்ரீவியஸ் இயர் கொஷின்ஸ். இட்ஸ் நாட் டிஃபிகல்ட். ஐம் சாரி. அது வந்து எல்லாமே ப்ரீவியஸ் இயர் கொஷின்ஸ். நிறைய கொஷின்ஸ் ப்ரீவியஸ் இயர் கொஷின்ஸ். ஓகே, யா கொஞ்சம் லென்த்தியாக இருக்கா? இல்லை, ஓகே, வி ஹாவ் ஒன் கொஷின் இதில் ஃப்ரம் ஆர் ஃப்ளூயிட்ஸ் சாப்டரு. ஒரு கொஷின் தான் இருக்குது. so many questions from 12th standard syllabus. ஓகே, டன் பக்கா. வில் அது பார்ப்போம். ஓகே கைஸ், ஸோ அந்த கொஷின் எல்லாம் வந்து ப்ரீவியஸ் இயர் கொஷின்ஸ் தான். செட் 6 டிஃபிகல்ட்டாக இருக்கா? ஓகே, நான் மேலன் சொல்கிறாரு செட் 6 டிஃபிகல்ட்டாக இருக்குன்ட்டு. நான் போய் பார்க்குறேன் கொஞ்சம் பொறுமையாக. பட் இப்போ சும்மா ஸ்கிம் பண்ணதில், ஆனால் இந்த கொஸ்டின் பேப்பரில் வர மாதிரி நீட்டில் வருமா? எஸ், இந்த லெவலை விட கொஞ்சம் அதிகமாக வந்துச்சு நினைக்கிறேன் 2026 2025 லாஸ்ட் இயர் பேப்பர். ஓகே, இதுக்கு மேலே நான் டைம் வேஸ்ட் பண்ண விரும்பல. ஃபைன் கைஸ், மேர்லின் சொல்கிறாரு செட் 6 டிஃபிகல்ட், ஐ வில் செக் இட் அவுட். யா, இந்த மாதிரி தான் வரும். சௌமியா கொஸ்டின் பேப்பர் இந்த மாதிரி, அண்ட் இட் வில் பி லிட்டில் மோர் ஹையர் லெவல்னு வச்சுக்கோங்களேன். ஃபைன். ஃப்ளூயிட்ஸ், வாட் ஆர் ஃப்ளூயிட்ஸ்? you would have learned நீங்கள் ஃப்ரம் யுவர் 11th ஸ்டாண்டர்ட் இப்போ படிக்கிறீங்க. From your grade 1 to grade 10 you would have studied solids, liquids and gases. அதுக்கப்புறம் you have other states as well. But யூஸ்வலாக சாலிட் இருக்கும். It's either solid, say like this pen, the only thing I have here, and liquid, water, and gas, the oxygen we breathe. Fine. So okay, now there is this term called fluids. Okay, fine. Hi அண்ணா, என் பேர் ஜீவன். ஓகே, ஹாய் ஜீவன், தேங்க்யூ. ஓகே, fluids are something, okay, those substances which flow, okay, which flow when external force is applied. See, I have air, okay. இப்போ வந்து you can't see, but இப்போ நான் கை இப்படி force apply பண்ணும்போது air particles which were present here previously, they would have moved there. They did move, okay, but I can't prove it. Say smoke இருக்கணும், smoke நீங்கள் இப்படி தள்ளும் போது they'll move, right? Fine. ரிவரில் தண்ணி, it goes on, it flows, right? Fine. These are fluids for you. So something that flows. Flows when external force is applied. Fine, done, paka. Fine. இப்போ வந்து there are so many things, studies of fluids. You have fluids oda statics, fluid oda dynamics. Okay, ஸ்டாட்டிக்ஸ் நான் வந்து ஃப்ளூயிட் ஸ்டாட்டிக்காக இருக்கும்போது, ஃப்ளூயிட்ஸ் அட் ரெஸ்ட் அதை பற்றி படிக்கும்போது, டைனமிக்ஸ் வந்து ஃப்ளூயிட்ஸ் இன் மோஷன். ஜென்ரலி தி ஆல் கம் அண்டர் ஃப்ளூயிட் மெக்கானிக்ஸ், இந்த சாப்டரோட பேர். ஃபைன். ஓகே ஓகே, டன், பக்கா. ப்ரெஷர் நியூட்டன்ஸ் லாஸ் ஆஃப் மோஷன்லேயே எவ்வளோ. நீங்கள் எந்த காலேஜ்? ஐ எம் ஃப்ரம் மெட்ராஸ் மெடிக்கல் காலேஜ். Okay, fine. Pressure வந்து it's so obvious, everyone knows this. It's force applied per unit area. Okay, units வந்து unit by meter square or Pascal. The dimensional formula வந்து என்னதுலாம்? m mass into acceleration ml. ஆனால் l கீழே இருக்கு, l minus 2, l minus 1, acceleration t power minus 2. This is the dimensional equation. Okay, m power 1, l power minus 1, t power minus 2. Fine. Okay. ஆனால் மார்க் டெஸ்ட்டில் எப்படி நான் பூஸ்ட் பண்ணுறது? வீக்லி டெஸ்ட் 720, டெய்லி ஸ்டடி பிளான். ஓகே, விஐபி 1 2 3 த வின்னர், அவங்க பேர் எனக்கு தெரியல. ப்ளீஸ் வெயிட் till the end of this class. Okay, நான் asking the question again because I've started it. I don't want you guys to cut the flow இப்போ. I was discussing all those questions now. Okay, fine. why in the pressure, this pressure concept is pretty simple, okay? When you have a knife, okay, a knife is able to cut through stuff, okay? And sometimes you call it blunt, sometimes it's sharp, okay? When it's blunt, okay, blunt இருக்கும்போது it's nothing but it's இதோட அந்த ஏரியா இருக்கு இல்லையா, இந்த ஏரியா it's large இருக்கும்போது it won't be able to cut through stuff properly, even though if you apply the sufficient amount of force, okay? இப்போ நான் 10 Newton force-க்கு I'm having this huge area and I'm cutting, I can't cut through myself, okay? இதே force வந்து நான் ஒரு proper knife வச்சு கொடுத்திருந்தேன்னா it would have cut my skin, obviously. So this is what pressure does, okay? The pressure வந்து it shows how much force is exerted per unit area. ஒரு யூனிட் ஏரியாவுக்கு நிறைய ஃபோர்ஸ் போச்சுன்னா as a whole they experience more force, okay? அதே வந்து இப்போ when I'm using this pencil, apple pencil to cut through my skin, area is more, fine, area is more, because of which என்னோட force gets distributed, fine. இப்போ நீங்க if you see it's not based on pressure but still force reduce பண்றதுக்கு, if you see catching cricket ball na, they will இங்கே அப்படியே ஸ்டாப் பண்ண மாட்டாங்க, but they will drag it, okay? It has nothing to do with pressure. ஆனால் நான் சும்மா சொல்கிறேன், because when you drag the ball, okay, you are reducing the force acting on you கொஞ்சம் கொஞ்சமாக, because if you சடனாக நீ force I mean சடனாக பால் ரெஸ்ட்டு கொண்டு வரதை விட கொஞ்சம் கொஞ்சமாக if you gradually decrease its speed, it won't hurt you because there is a constant rate of deceleration. கொஞ்சம் கொஞ்சமாக it will decelerate, or சடனாக decelerate ஆகும்போது the deceleration will be more, it will have more effect on you. But it has nothing to do with pressure, but it has something to do with force, because force is what force and momentum are related, and momentum அதான் இங்கே சேஞ்ச் ஆகுது, okay, fine. That was for your understanding, okay, fine. நம்ம காலேஜ் ஆன்லைன் கேமிங் டோர்னமெண்ட் இருக்குமா, லைக் ஃப்ரீ ஃபயர், பப்ஜி, கல்ச்சரல்ஸ் இருக்கும்னு நினைக்கிறேன். ப்ளீஸ் டோன்ட் ஆஸ்க் சச் கொஷின்ஸ் இப்போ. ஓகே, டென்சிட்டி, ஓகே ஃபைன். இப்போ திஸ் இஸ் அ வாட்டர் பாட்டில், ஓகேவா? இதில் வந்து ஐ ஹாவ் வாட்டர் தான். The same stuff, okay? Same water bottle, instead of water, if I filled it with, say, mercury, say I filled it with gold, okay, liquid molten gold for the same volume, and I measured them separately in tiny weighing scales, okay? When I see for the same volume, my water had some mass, my mercury had some mass, my gold had some mass, my silver had some mass, okay? Why so? Because because their densities vary. Now what is density? Say I have water, okay? Water la வந்து generally water, if you take for 1 liter na, and 1 liter will weigh 1 kg, fine. Other if you take mercury, it will weigh around 7 or 8 kg, I think. It's somewhere around that, yeah, fine. Because the amount of mass present per unit volume in mercury is more than that of water, okay? So இப்போ வந்து நீ ஒரு okay, this container la there is some water, there's some water everywhere, okay? It's not nice. Idhila there is some water, say these are water molecules. I'll atomic level I'll give you understanding. ஒன்று வந்து mercury இருக்கு இல்லையா, if I use mercury, the- say these are your mercury atoms. Okay, water molecules வந்து one water molecules ஓட mass is less. Okay, it molecular mass is less. இதோட molecular mass is more. One. The other reason is because these are closely packed. They are more closer than that of water. Second reason. So these are the two reasons why densities of substances vary. Okay, இன்னும் நீங்கள் இன்ஆர்கானிக் கெமிஸ்ட்ரியில் போனீங்கன்னா யூல் ஹாவ் பெட்டர் அண்டர்ஸ்டாண்டிங். ஏன்னா டென்சிட்டிஸ் சில இடத்துல there are anomalies. Okay, but this is basic stuff. I have one question for you before after this. Density nothing but mass per unit volume represented by kg per meter cube or gram per centimeter cube. Okay, fine, paka. It's a macroscopic thing because you can change densities. Okay, you can change densities. It's positive and scalar. Fine. Now, why density in fluid mechanics, you may ask? Take air and water. Okay, you would have known our capacities, right? Lung capacities, FRV, ARV, tidal volume. Say my tidal volume is 500 ml. Okay, and and the 500 ml of air, to blow it out to some distance. Okay, I would use some force per that unit volume. Okay, say if instead of air which is filled in my lungs, I had water, 500 ml of water, and the water to push it out, okay, through my nostrils, to push it out through the same distance as I pushed my tidal volume. Okay, I would require more force because water is more dense than air. Fine. In the case water required more force per unit volume than air. அதனால we can say that I require more force to put on that. We can say that air is less dense than water. That's why the concept comes. There are a lot of things other than this alone. Okay, we can I'll discuss. Okay, fine. Now there is something called as relative density. Before that, let's say I have an object with the mass of 500 grams. Okay, and volume of uh 50 centimeter cube. Okay, and I'm placing it in water, in the mass object. I'm placing it on water. Okay, fine. இப்போ வந்து when I place this object, will it float or will it sink? Okay, first let's find its density. Water density is nothing but 1 gram per centimeter cube. இதோட density is nothing but 5 grams per centimeter cube. Okay, so our the object will definitely sink because object density is greater than 1 gram per centimeter cube. So object will definitely sink. Okay, this is a pretty basic understanding you supposed to have for density SIPO at this time. Okay, now relative density. Relative density is when you compare two densities. When you write density of one with respect to another. Fine. Usually in the chapter the relative density of any substance is relative to water. Okay, so if I have 50 uh, gram per centimeter cube, okay, relative density with water, now water is nothing but 1 gram per centimeter cube. அதாவது 1 liter பாட்டிலில் I'll have 1000 grams of weight. Okay, fine. So the relative density will be 500. This is also called as specific density. Okay, so the substance or density is 500 times more than that of water. Okay, fine, done. Okay, now let's say one more thing. Water or a density decreases when it's cold. Okay, see, first I told you when molecules come closer. Okay, when they come closer, um, and their mass gets concentrated more in a smaller area, because of which அவங்களுக்கு density அதிகமாக இருக்கும். Fine, this is simple. But for water, when you cool stuff, it gets solidified. Everyone knows this, correct? நீ ஏதாவது கூல் பண்ணும்போது it gets solidified. But water நீ கூல் பண்ணும்போது when it turns into ice, uh, which is obviously a solid form of water. Okay, it it loses its density. அதோட density குறையும். Okay, when it's at 0 degrees Celsius, okay, when it's a pakka solid, the density is actually decreasing. Okay, see, this is my temperature, this is my density score. For understanding sake, this is not entirely accurate, but still density is like this. இந்த மாதிரி ஒரு graph வரும். Okay, இதில் வந்து the maximum density is at at 4 degrees Celsius maximum. Okay, இது ஏன் நடக்குது, இது வந்து I'll discuss it in thermal properties chapter. இப்போதைக்கு it's not required, but yeah, fine. Okay, so okay, no one has any doubts. Okay, I'll start with the next topic. Okay, density of a mixture. Okay, say take a mixture. Okay, ஒரு மிக்சரில் வந்து ஐம் ஹேவிங் மல்டிபிள் டென்சிட்டிஸ். இது எப்படி கேல்குலேட் பண்ணணும்னு வச்சுக்கோ. ஐம் ஹேவிங் அ மிக்சர் ஆஃப் one substance and mixture of another substance, and they're having different densities, different volumes, so they have different mass. Okay, in general, density is written as mass, total mass divided by total volume. Fine, total mass divided by total volume, right? So in the case lab, same having an object with density of d1, okay, with a volume of v1, with a mass of m1, okay, and you don't require d2 v2 m2. So the mixture or the total density will be total mass by total volume. Total mass is nothing but m1 plus m2 divided by v1 plus v2. Simple. This is super simple. But now I want this in terms of density only. I want this in terms of density. அதை நான் எப்படி எழுதுவேன்னா see d is equal to m by v. m க்கு பதிலாக I'll write dv. m equals to d into v. Okay, this is my kutti thing. I'll write it here. So my mass will become dv, so d1 v1 plus d2 v2 divided by v1 plus v2. This is how we find density of a mixture. Okay, fine. Okay, done. Okay. Hello. Ask me in the chat if you have any doubts, guys. Come on. Okay, fine. Now I have a question for you. When two equal volumes of metals, okay, two equal volumes of two metals, okay, two equal volumes of two different metals I'm using, okay, or not a specific gravity is 4, okay, you know not a specific gravity, I don't know, and their mixture has a specific gravity of 3. I'm supposed to find the specific gravity of the second substance, okay, sorry. So we're supposed to find the specific gravity of the other substance. Let's see how we're gonna find. Okay, very easy, simple. I am having density of 1, and I'm having the density of the resultant stuff. Okay, in the equation which if we solve, okay, d1 v1 plus d2 v2 divided by v1 plus v2 equals to 3. Okay, since volumes are same, d1 plus d2 by v2v v cancel, so d1 plus d2 by 2 is equal to 3. Simple. இப்போ ஒன்னோட மட்டும் we found out that it's 4 specific gravity. Fine. So if its specific gravity is 4, the other one will be 2, right? 4 plus d2 equals to 6. d2 equals to 2. Okay. So this is my basic density based question. Okay, fine. Okay, clear Anna, thank you so much for telling me. வேற யாரும் சொல்ல. Okay. Okay, அவ்வளோதான். So only Soumya is clear with the concept. Now we have something called as Pascal's law. Okay, Pascal law oda thing is same. Okay, idea of this Pascal law is same. I don't have to derive it இப்போ because derivation is not required நமக்கு. But I'll tell you the statement. Okay, I think I can derive it, but இப்போ derive பண்ண வேணும் தான். But okay, clear now. Okay, so see Pascal's law. Okay, very simple. Say I'm having water இங்க. Okay, இந்த water bottle this இந்த ஒரு லைன் இருக்கு தெரியா, the top thing, leave it. Okay, இப்போ வந்து இந்த water bottle if I take any horizontal plane, okay, any horizontal plane, any horizontal plane, the pressure in that horizontal plane will be constant. Okay, is constant in a horizontal plane is inside the fluid. Okay, so if you take anything, okay, these are all basic stuff. இப்போ இது என்ன questions வரலாம் வராட்டியும் போகலாம், but still. Okay, okay. Fine. Okay, barometer is too இப்போ வேணாம், but I'll tell you how Pascal's law வேணாம், but I'll tell you how pressure increases with depth. Okay, now just everyone listen here. Okay, all your attention on the screen. I'm taking a container or containerல, let's take a bigger one. Okay, the container I have filled it with fluid. I filled it with fluid. Okay, in ஒரு slide பார்த்தீங்கன்னா you'll understand two main concepts. One வந்து variation of pressure with height. Another, you'll understand why buoyancy is there. Okay, what is buoyancy? Why do you have buoyancy? Fine. Now let's take an imaginary cylinder in the or entire segment. We'll take one cylinder portion மட்டும், and we'll study that. The cylinder portion. Okay, it's so difficult to draw a cylinder here. Just imagine this as a cylinder. Okay, this is so bad. Mac. Why is it not working properly? Sometimes I hate iPad, guys. It doesn't respond properly. I need a cylinder. Okay. Okay. So this is my cylinder, okay. I'm taking imaginary cylinder in this fluid. Fine. What am I going to do? It's fine. Okay. Let's understand konja konjama. Okay. From Pascal's law, which I didn't derive because it's not necessary. We know that ஒரு horizontal planeல pressure is constant. Okay. Fine. Now we know இந்த தண்ணி இருக்குல்லையா, this imaginary cylinder inside my bucket or inside my container, it's stationary. This cylinder is not moving. It doesn't have any external unbalanced force acting on it, so it's stationary. Okay, this point is clear for everyone. Okay, it's stationary. So when this is stationary, I could say that it has some force balancing because you have mg acting downwards. Okay, when I take the thing of the cylinder radius is r vechko, its volume is pi r square h times density of water will be my mass into g, will be the force acting downwards. Okay, fine. Now if you see, it's stationary, so there is some force acting which is given by the water to keep it stationary. That's our buoyant force. அது நான் இன்னும் டீட்டெயிலாக இல்லை எக்ஸ்பிளைன் கொஞ்ச நேரத்தில். But here what I'm supposed to find now, when I take the pressure in this point and when I take the pressure in this point, there is a variation, there is a difference. Okay, this difference is because of the height at which it's taken from the ground level. If I take pressure at this point, okay, the pressure at in the area இருக்கிற pressure in the area like a pressure, okay, it is because of the water above it, correct? It's because of the water above it. And in the area like a pressure, it's because of the water above it again. It's because of the water above it. Fine. So this is what I wanted to tell you. Okay. Pressure is because of mass per unit area. So inga vande this mass, first one ku mass is above it in the level. I can't touch it. Okay, mass is in the level. For the second one, the mass is the entire thing from the first one to second one. So it includes in the cylinder as well. Fine. So this is our variation of pressure with height. More எவ்வளோக்கு depth நீ போக the amount of substance above you, it increases. Okay, irrespective of your area, you could say that you experience forcing. Fine. Okay, now if you take pressure here, take this as P1, this as P2, my P2 minus P1 will be equal to H rho g. If you carefully observe, say the pressure is pressure is related only with height. Okay, எப்படி வந்துச்சுனா இது எப்படி வந்துச்சு I'll derive கொஞ்சம் இங்க. If you see pi r square rho g h is my pi r square h is my volume, rho add பண்ண mass into g. This is my first thing oda, this is my mg. Okay, mass per area per unit area தான் நான் வந்து sorry weight per unit area is my pressure. Okay, force per unit area or weight per unit area. இங்க வந்து if you want to take area, I'll take pi r square தானே, pi r square, so it gets cancelled, so my pressure is h rho g. This is my pressure. So from this you can find that you can easily tell that you can easily say that okay, pressure is related to height. Okay, just height. Now consider the depth of an ocean. Okay, or ocean, it say the depth is I don't know properly, but say it's 1 kilometer. Or ocean there is so much water. Okay, ocean has so much water, and அதோட deepest point it's which is 1000 meters below, it has some pressure of h rho g. That h is 1000, rho is density of water, and g is acceleration to gravity. Okay, fine. Now consider a long narrow tube, very narrow, super narrow, like in the pencil இருக்கு இல்லையா, இந்த pencil ஓட thicknessக்கு there is a tube which is also 1000 meters, in height. Okay, and the 1000 meters if I fill water, okay, if I fill water, அதோட bottom most point லையும், okay, the pressure will be the same that to that of the ocean. Okay, so what I want to tell you here is this pressure, it depends on only the height from which height at which the substance is present, and not the amount of substance actually present. Okay, so yeah, நான் என்டிஏவோட சாம்பிள் போய் எப்படி டெவலப் பண்ணுறது, கோ டு என்டிஏ நேஷ்னல் டெஸ்டிங் ஏஜென்சி, அங்கே போய் மார்க் டெஸ்ட் இருக்குது, யூ கிவ் மார்க் டெஸ்ட் அதில், and if after you give mock test you'll have some which paper you would like to test, give NEET, which paper you want, physics not physics, and mock test அப்படியே ஸ்டார்ட் பண்ணுங்க. This has been provided from long back, ரொம்ப நாளாக கொடுத்துட்டு தான் இருக்காங்க. Okay, I had to make one statement அது சொல்லியாச்சு, because it's so fascinating because when something is so thin like this, okay, could replicate the pressure of an entire ocean, it's so fun. So that's why I love physics. Okay, barometer. Okay, paka, this is like the foundation thing from where the chapter speeds up konja konjama. Barometer, what happened? Okay, barometer, you would have heard somewhere that barometer தான் வந்து it's the atmospheric pressure நம்ம வந்து கண்டுபிடிக்கிறோம்ட்டு. Let's see how ஒன்றும் இல்லை, you'll have mercury. Okay, in the barometer you could use any substances. We use mercury. There is a thing, let me construct one barometer for you. அடிக்கடி மேலே போயிடுது, it's so annoying. Okay, I'll make a barometer. Okay, very 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 simple. Okay, okay, So the build is simple. Okay, you have a cup here. Okay, okay, இதில் வந்து it is filled with mercury. Okay, paka, done. Fine. இப்போ வந்து ஒரு test tube la full-ஆ I am filling it with mercury again. Okay, and அதை என் தம்மில் வச்சு ஹோல்டு பண்ணிட்டு I am inverting it இப்படி. Let's not. Okay, I am inverting my test tube இப்படி. This is my test tube. The test tube I'm having some substance. I'm using mercury again. The mercury full-ஆ வச்சு this is my test tube. Mercury is filled. நான் finger ப்ரெஸ் பண்ணிட்டு நான் அப்படியே திரும்ப அந்த mercury கப் இந்த சாசருக்குள்ளே வைக்கிறேன்னு வச்சுக்கோங்க. It's not proper. It's a பீக்கரில் வச்சுக்கலாம். When I keep it, okay, இந்த mercury ஃபஸ்ட்டு ஃபுல்லாக ஃபில் பண்ணியிருப்பேன். But when I place it இந்த மாதிரி, some mercury it comes out into the beaker. Okay, and remaining mercury and or level போய் it will stop. Okay, ஒரு level is stop இந்த மாதிரி. Mercury will stop at this level. Okay, this is what my barometer simpler இருக்கும். The thing is, when you have mercury and when you place it in such a manner, okay, இது வந்து it's simple to device to find our atmosphere pressure. See, when you do this, okay, இங்க வந்து there will be some vacuum. Okay, not technically vacuum, but you could tell there is atmospheric pressure. Okay, atmospheric pressure. This atmospheric pressure will push mercury. Okay, அப்போ இந்த லெவல்ல if you calculate pressure, okay, we from Pascal's law we know that at every horizontal plane, okay, the pressure is same. So இப்போ இங்க வந்து if you take atmospheric pressure to have impact, okay, in the ஏரியால இந்த இடத்துல there will be the same pressure. Okay, atmospheric pressure or for pressure is exerted in this area. In the test tube கீழ இருக்கிற ஏரியால there is also same force because Pascal's law. Okay, same force is only same pressure is only acting on this area as well. But inga actor of pressure is due to the mercury which is filled in that thing in my you get it la? Because of the mercury present in the test tube, there is some pressure at this point. There is some pressure at this point. Because there is some pressure at this point. The same pressure is also present here because atmospheric pressure. So atmospheric pressure at at this point is equal to pressure exerted by mercury at this point. Simple. So my atmospheric pressure P naught is equal to rho GH, where rho is the density of my mercury and H is this height. Simple. Okay, this is my barometer. The barometer la வந்து approximately this height is 76 centimeter. So wherever you have questions called 76 meters of HC, centimeters of that HC, that's your atmospheric pressure. Okay, fine. Paka. Okay. Now our points சொல்ல வந்த இல்லையா, the basics of this Pascal's law. And my in the page. Yeah. If you take container, say it's in the shape la. I'm unable to draw. Okay, I'll try to. Okay, இந்த மாதிரி ஒரு container வச்சுக்கோங்க. And then same height layer having this one. And then I'm having this one. Okay. Okay. Now if you observe, their heights are same. Heights are same. Okay. So நீ இப்போ வந்து ஒரு plane பார்க்கணும், இந்த plane வச்சுக்கோ, the horizontal plane ல. If I'm if I'm about to check for pressure na, the pressure at this point and this point and this point will be equal as long as the fluids in this one or substance in this one and S3, S1, S2, S3 are same. Okay, as long the substances inside them are same, the pressure in the horizontal plane will be same. Okay, this is my basic thing. Actually, I wanted to you to know, very important. The same thing நீ எப்படி வேணா ஷேப் எடுத்துக்கோ. இட் கேன் பி இந்த மாதிரி எஸ் ஷேப்லலாம் கொடுத்துருப்பாங்க கன்ஃபியூஸ் பண்ணுறதுக்கு. பட் ஸ்டில் ஃப்ளூயிட் லெவல்ஸ் வந்து இவ்வளோ வரைக்கும் தான் ஃபில் ஆயிருக்கும், இவ்வளோ தான் ஃபில் இருக்கும். ஸோ அப்போது அந்த எண்ட் பாயிண்டில் வந்து பிகாஸ் ஆஃப் தட் ஹைட் வாட் எவர் ப்ரெஷர் இஸ் தேர், அதான் வந்து நீ ஃபைனலாக கண்டுபிடிக்க மாதிரி இருக்கும். தென் ரேதர் தென் தி அமௌண்ட் ஆஃப் சப்ஸ்டன்ஸ் இன் இட். ஓகே, okay. I thought parameter and then next variation. Hydraulics is a lovely topic. Okay, lovely topic. Okay, there is something called as variation and hydraulics. இதுக்கப்புறம் you have buoyancy, Archimedes principle, flotation, ideal fluid minor, equation of continuity, Bernoulli's theorem, Torricelli's law, Magnus effect, viscosity, Stokes law, terminal velocity. Yeah, you have pretty கொஞ்சம் அதிகமாகவே இருக்கு. Okay, fine. Okay, let's solve few questions. Okay, I have like every class க்கு நான் வந்து ஒரு 100-150 questions I have கையில். ஆனால் சால்வ் எல்லாமே பண்ண முடியல. பட் I love solving questions. Okay, thanks அண்ணா. Let's talk about variation of pressure. I don't have any questions because so far the topic is like so malapla, so I don't have any paka questions. But still, yeah. Mm. When you have something accelerated, okay, I'll give you a basic idea. Same தண்ணி இருக்கு ஒரு கண்டெய்னரில். இதில் நீங்கள் கொஞ்சம் நல்லா பார்த்தீங்கன்னா வாட்டர் வந்து இப்படி போகும். when I accelerate இந்த டைரக்ஷன் ஆக்சிலேட் பண்ணும்போது water will be like this. சேம் ஆக்சிலேட் கிட்ட in this direction. ஸோ கண்டெய்னர் இருக்க தண்ணி வந்து இந்த டைரக்ஷன் இருக்கும். ஓகே, லெட்ஸ் டேக் அ பாயிண்ட் இங்கே, இந்த பாயிண்ட்டு அண்ட் ஓகே சிலிண்டர். இப்போ இந்த சிலிண்டரில் ஐம் சப்போஸ் டு ஃபைண்ட் த ப்ரெஷர் வேரியேஷன். பிகாஸ் நான் இவ்வளோ நேரம் சொல்லிட்டு இருந்தது ப்ரெஷர் இஸ் கான்ஸ்டன்ட் இன் ஹாரிசான்டல் பிளேன் பாஸ்கல்ஸ்லாம். பட் இந்த கேஸில் வந்து when it's accelerated in this direction, when it's accelerated in this direction, okay, there is a variation in pressure because இங்கே ஹைட் இருக்கு பாரு, height of substance. இங்கே வந்து இட்ஸ் h, இங்கே வந்து ஒரு h, இன்னும் குட்டி h. there's a difference h1 வச்சுக்கோ, இது h2 வச்சுக்கோ. Okay, this is h2, this is h1. Okay, the difference in pressure at these points will be one வந்து because they are in the same horizontal plane. Okay, is supposed to have the same thing, same pressure, but because it's accelerated, the amount of substance on top varies. Fine, because of which there is a pressure variation at, say this is p1 and this is p2. p1 and p2 there is a difference in pressure, and this pressure is variation is nothing but h2 minus h1 into rho g. This is the variation in pressure. Fine. Clear? Okay. There are a lot of things which you can do here. Okay, fine. Same, it's accelerating in the direction, yeah. அப்போ obviously இந்த இந்த டைரக்ஷனில் ஒரு ஆப்ஜெக்ட் மூவ் ஆகுதுன்னா பின்னாடி இந்த ஃபோர்ஸ் இஸ் மோர் தென் தட் ஆஃப் திஸ் ஃபோர்ஸா. ஸோ ஆப்வியஸ்லி இந்த ப்ரெஷர் இஸ் மோர், which is அதை வச்சு you can easily I understand this thing. Now say the length of this imaginary cylinder is L. Okay, okay, and in the point I am drawing a line. Okay, and I'm considering an angle of theta here. This is h2 minus h1, this is L. Okay, if I take tan theta inga, this is the difference in pressure. Tan of my tan theta is equal to h2 minus h1 divided by L. Okay, you get it, h2 minus h1 is equal to L. Okay, Now I need to express tan theta in another term as well. அப்போ பண்ணா வந்து I'll get the relation between acceleration and the height difference thing. Okay, fine. See, this is my what equation. Okay, this is very basic thing. Now little into the subject. Okay, we know that இப்போ ஒரு ஆப்ஜெக்ட் இப்படி இந்த டைரக்ஷனில் மூவ் ஆகணும்னா there will be more force here than the force இங்கே கரெக்டாக. அப்போனா my P2 into in the say this area say this area is P2 into and the area minus P1 into that area will be equals to mass times acceleration. Okay, mass is nothing but area into length of volume times density into acceleration. Fine. Okay, now I divide everything with a. P2a minus P1a equals to, so divide everything with a common irukka a. So pressure difference is equal to L density into A naught. I know this. What else do I know? Pressure density is equal to H2 minus H1 rho GH, correct? Obviously. So this can be written as H2 minus H1 into rho G. Okay. L rho A naught cancel. H2 minus H1 divided by length is equal to A naught by G, which is my tan theta. So tan theta is also equal to A naught by G. This is what I wanted to prove. Okay, done, pakka. Okay, fine. Okay, let's talk about hydraulics. You have seen hydraulic brakes, lot of hydraulic stuff in your life probably. Well, the concept is same, simple. Okay, but the application is so beautiful. Okay, see, ஒரு சின்ன ஒரு incompressible fluid இருக்கு வச்சுக்கோ. Okay, ஒரு incompressible fluid. அந்த fluid மேலே ஒரு சின்ன ஹோல், say it's around 5 centimeter square. Okay, அந்த 5 centimeter squareல okay I'm applying some force. Okay, now that force will be will be pressure to that fluid. Okay, say ஒரு 5 centimeter square area I'm applying 10 newtons of force. 5 centimeter square 10 newtons. So the pressure inge will be 10 divided by 5 into 10 power minus 4 to 20,000 pascals or 20,000 newton per meter square. Now this entire thing I am converting it to an area, a huge area of 1 meter square or one. See, there is concept one there. ஓகே, ஒரு சின்ன ஹோலு, அதுலேருந்து ஐம் ஏபிள் டு புஷ் இட். தெர் இஸ் ஃப்ளூயிட் இன்சைட். There is fluid inside. Okay, now in the entire thing ஒரு பிளாட்ஃபார்ம் இருக்கு வச்சுக்கோ. ஓகே, ஒரு பிளாட்ஃபார்ம் இருக்கு. Okay, so when I press it down, this platform goes up. Okay, fine. This is very ஒரு மாதிரியான depiction, but still say 20,000 newtons per meter square. இப்போ இந்த சர்க்கிளோட ஏரியா சே இட்ஸ் 0.5 meter square. Okay, 0.5 meter square. See, this is 1 meter. So 20,000 newtons, 0.5 meter square la, the force which is applied anga will be equal to 10,000 newtons. Okay, we'll just see how big is it. I'm having a 10 newton force. Okay, a 10 newton force making a 10,000 newton force just by pressing it through a small area. Small area. Okay, that's the power of hydraulics. That's why it's used everywhere. It's very simple. நீ ஒரு சின்ன அமௌண்ட் ஆஃப் ஃபோர்ஸ் வச்சு யூ கேன் லிஃப்ட் வெரி ஹெவி ஆப்ஜெக்ட். இப்போ நீங்கள் போனீங்கன்னா கார் வேயிங் மெஷின்ஸ் எல்லாம் இட் வில் பி தேர். எவ்ரிதிங் இஸ் பேஸ்ட் ஆன் திஸ் கான்செப்ட் ஆஃப் ஹைட்ராலிக்ஸ் தான். இப்போ பிரேக்கிங் ஸ்டப், பிரேக்ஸ் எல்லாம் வந்து ஹைட்ராலிக் பிரேக்கிங் சொல்லுவாங்க. ஆல் இதுதான், வென் யூ பிரேக் இட் தெர் இஸ் ஃப்ளூயிட் விச் கோஸ் அண்ட் புஷஸ் another thing similar to this platform, and சின்ன ப்ரெஷர்லேயே வந்து you are able to push it more. I mean, you're able to have reciprocated a larger force. These are basics of hydraulics. Okay, yeah, I think இதோட இப்போதைக்கு I'll take a break. We still have பாதி slides remaining. Yeah, again, yeah, we have around 27 slides more. Okay, so halfway to the class. Let's take a small break because I have something because I feel so tired. Okay, இப்போ 8:15 class வந்து 8:35 ஆரம்பிச்சிடலாம். Okay, see you guys கொஞ்ச நேரத்தில். Hello. Guys. If you, he's okay. உங்களால் 9 hours 2 days நடத்த முடியுமா? I could take, if I had time now, I could take. But I don't have. See, I am having college. I have to balance college. I have to balance my practicals. I have to balance my exams. I have to balance this with all the other things I'm already in. Some research stuff. I have, I'm in a band as well. So yeah, it's கொஞ்சம் கஷ்டம். I can't take 9 hours, but I could try though. Okay. But I would love to take class in depth like இதுக்கும் எல்லா டாபிக்கும் கொஷின் சால்வ் பண்ணுறது I would really like to do, but அவ்வளோ டெப்த்தாக I'm not having enough time. I'm sorry. Already 6 o'clock I should come, but since I'm fasting, I should be I have to break it at 6:25, and then I'm starting class at 6:30. அதுவும் அப்பப்போ class அது. So tomorrow I have an exam, pharmacology practicals. இது முடிச்சு I will go and study for that as well. And I have an IA tomorrow morning ஒரு IA, afternoon practical exam. So yeah, 9 hours இருக்கிறது வந்து it's little difficult. I can't. But I would really love to. I would love to take classes with such depth. Okay, like all questions, all formulas, all models, எல்லாத்தையும் சின்ன சின்ன இன்ட்ரிகேட் டீட்டெயில்ஸையும் வந்து இன்ட்ரிகேட் ஸ்ட்ரக்சர் ஆஃப் த சாப்டரையும் கவர் பண்ணி எல்லா பாயிண்ட்ஸையும் சொல்கிறது I really love to, but yeah, that's how it is. So yeah, what's buoyancy? Okay. Let's understand buoyancy. Okay, I want everyone's attention here on the screen. Okay, I'm a little bit energetic, boy. I had some caffeine. Okay, fine. Okay, fine. Now the same example. Okay, let's consider a container. And the container, okay, in the bottle, but still, if you take this water bottle full of water, okay, and the water, if you see, when I keep it placed on the table, all the particles are stationary. There is no movement. There will be little movement, but netta there won't be any movement. Okay, fine, which is obvious. So since there is no net movement, I could tell that, but still, okay. There are two points I need to discuss. One, we figured out that there will be pressure due to height or depth. There will be increased pressure. Okay, in the same concept. Okay, the same exact concept we'll use in our surface tension. Okay, we'll use. Okay, so if you see this is my container which is filled with some liquid. Okay, Paka. Okay, something like this. I can't fill. Okay, fill பண்ண முடியுமா அப்படியே? No. So yeah. இதில் வந்து if you say take a point இங்கே, this point, இந்த பாயிண்டில் பார்த்தீங்கன்னா இந்த பாயிண்டில் ஒரு பார்ட்டிக்கல், I zoom it in, see there is a particle, இந்த பாயிண்டில் there is a particle. Okay, this particle is stationary even though there is pressure build up in the entire thing, even though there is, it's a depth d ன்னு வச்சுக்கோ, it's a depth d na, even though it's experiencing rho g h amount of force downwards, it's still stationary, it's still there. Okay, it's still there. Reason என்ன? Because there is an extra force acting here on this particle. Netta one, there is pressure இவ்வளோ into area, if you add you will get the force. And the force go, there is a resultant upward force keeping it stationary. Okay, this is one thing I need to tell you. இப்போ now consider now these liquids, these fluids are like stupid. Okay, they don't have brain. Okay, not being too harsh, literally they don't have any brain. So if I replace, okay, say I have in the molecule of water badala I am replacing a molecule of, say, a rock or a mineral liquor, say I'm having iron, something in the water or a volume la I'm adding iron. Okay, it will think that that volume is occupied by water only and it hasn't been replaced by iron, and it still pushes the thing with the same force, which is rho g h, to keep it stationary. Fine. Okay, now இது வந்து ஒரு பாயிண்ட் பார்த்தோம். Let's consider a volume. Okay, I am unable to fill this thing. How do I fill it? Let's say I'm having in the volume V. Okay, this volume V of water is stationary on the point because it is experiencing some force. Let's say it's in the same plane so that in the pressure is constant everywhere, but still there is some pressure upward. Okay, there is mg acting downwards. Okay, mg of this volume of water, but still it's acting, it stays stationary because there is an upward net force, which is your buoyant force, which keeps this water floating. Okay, which keeps this water stationary. Okay, fine. Okay, considering the pressure of at this point to be like equal because there is no height variation. Okay, so pressure and the எல்லா direction இருக்குமா? See, it all will get cancelled. So the only thing I'm considering here is my mg. Okay, so this is V. This is the exact way I learned this. Okay, the buoyancy, so I won't forget it. So this is V, and V oda mg மட்டும் active because there is pressure acting in all directions, so that netta there is no pressure on this thing. Okay, fine. So the only thing I have to compensate for is the mass times gravity of this water thing. Okay, now the mass is nothing but volume into density into g. This is my net downward force, and since it's stationary, the net upward force acting on it will be equal to the same. So this will be my F buoyant force. Okay, this is a lovely I really this is so good. Okay, you just think water doesn't have brain. Okay, so if I replace this entire volume with say a rock, okay, ஒரு rock place பண்றேன்னா rock வைக்கும்போது it will have the same, my rock has the same volume as the volume of this thing. Okay, so rock place பண்ணும்போது, okay, it will still experience this upward buoyant force. Okay, VTG, but since rock or density is more, rock or my mg is more mg than that of the upward force, so there's a net downward force acting on it due to gravity, which is nothing but mg minus vdg. Vdg is my buoyant force. What is V? The volume of the substance. D is the density of water, and G is the acceleration due to gravity, and M in the pocket is the mass of the rock. Fine, paka, easy, clear. இவ்வளவுதான் buoyancy. This is buoyant force. This is how things work. Okay, now there is a guy called Archimedes who figured this out. Okay, okay. Hmm. Okay. Hmm. Since we are considering volumes, okay, volume consider பண்றோம். In the case like if volumes were same, there's no reply here yet. Okay, still if the volumes were same, I could write mass of rock to be volume of rock into density of rock. Volume of rock, which is also the volume, into density of the rock minus volume on the density of water to G. இப்போ எழுதலாம். அக்கா okay, this is one another way you can write it, but still this is a basic concept of where this is. Now consider let's take consider a huge ship. Okay, huge ship. Okay, there's no reply, guys. If you understood not, please reply here. Okay. That's your buoyancy. Okay, இப்போ வந்து let's say I'm having an object. Okay, this object I'm placing it on the water. Okay, this is my Archimedes principle. If I'm placing it on water, the amount of according to this principle, the amount of lift equals to the weight of substance displaced. This is basic stuff. Everybody knows this. Okay, so yeah, so the weight of water that's displaced will be the amount of lift it will gain. Okay, fine. Here I told you in buoyancy, if my density is super high, density is greater than the density of liquid, substance is greater than density of liquid, the substance will definitely sink because mg won't be compensated. But if you think our ships இருக்கு இல்லையா, the ships which carry huge containers, okay, அதெல்லாம் வந்து they are made of metal completely. How are they able to float on water? That's a very good question to ask. Reason என்னன்னா, if you take individual மெட்டலோட சப்ஸ்டன்ஸை பார்த்தீங்கன்னா அதோட வால்யூம்க்கு அதோட டென்சிட்டி it will be same, okay. But when you construct it in a huge manner, okay, எவ்வளோ பெருசாக கன்ஸ்ட்ரக்ட் பண்ணும்போது there will be lot of air cavities. Obviously you have room இருக்கும், நிறைய ஸ்பேஸ் இருக்கும் கண்டெய்னர்ஸ் வைக்கிறதுக்கு. All that space will contribute to its volume. So that the volume will increase so much, okay, volume will increase so much that mass of the metal divided by volume, which is the density of the ship, will be lesser than the density of water. It will be so huge, so it will displace so much water, and the displacement of so much water is nothing but is what gives me the lift is equal to the, so the amount of lift equals the weight of substance displaced. So if I displace more water, I'll have more lift. If I have more lift, then means I'll float. Okay, fine. This is இது வந்து concept. Now I have one question, guys. One question. See, there is a boat. Okay, this is one question. This is very interesting, a thought-provoking question. Just think, there's a boat, okay, and there's a guy sitting on it, and he has some luggage as well. Okay, when he throws the thing, whatever he has in his hand, when he throws it into water, what will happen? Will the boat sink or will the boat rise? Tell me in the chat box. Will the water level rise or will the water level go low? Very interesting question. Just think of it. You're in a boat, okay, you're having something in your hand, say some mass, and you're floating, okay. When you're floating, you throw this object outside, okay, நீ வெளியே வீசிட்ட. After throwing it away, will the water level increase or decrease? No one seems to answer this. Come on, yara, at least try, bro. Come on. Okay, no one seems to answer. Okay, simple. See, when there is a boat, okay, I love this question. Okay, there is a boat, okay, and then there is you, and then you have something in your hand, okay. அதை வந்து நீ வெளியே வீசும்போது என்ன ஆகும்? நெட்டாக வந்து the water you're displacing will reduce. Initially you would have displaced so much water that the water comes up, it will risen up, okay. When you throw the mass away, what happens? The volume stays same, the mass reduces, okay. So that it means the amount of water shifted out, amount of water that had displaced would have reduced up. Okay, I'll explain. Okay, 1 minute. See, the first one, this is my total mass of the boat வச்சுக்கோ, mg acting downwards. இந்த mgக்கு காம்பன்சேட் பண்ணுறதுக்கு ஒரு v வால்யூம் ஆஃப் வாட்டர் வந்து டிஸ்பிளேஸ் ஆயிருக்கு. ஸோ தட் இந்த போட் இருக்கா, ஓகே, கன்சிடர் திஸ் அஸ் போட். இது வர மாட்டேது. திஸ் போட், ஓகே, த வாட்டர் வந்து என்ன ஆகும், it would have displaced இப்படின்னு வச்சுக்கோ, இப்படி இருக்கும். Okay, இப்படி இருக்கும் வச்சுக்கோ. When I throw the mass out, okay, it will become mg minus small mg. Yeah? So my mass of the boat is reduced. Okay, reduce ஆகும்போது என்ன ஆகும், the amount of water displaced to hold the boat in that place குறையும். So when that decreases, if when the amount of water displaced decreases, the levels will fall. Okay, so when you throw stuff out, okay, you're suppose you'll think that கம்மியான weight நான் வந்து இன்னும் மேலே வருவேன், வாட்டர் லெவல் வந்து கம்மி ரைஸ் ஆகும்ட்டு மீன். Okay, but it decreases. Fine. Okay, Archimedes principle. Yeah, that's what he said. This is the one liner of whatever he said. That's what I explained as well. Okay, done. Paka. Now there is a concept of relative density. Flotation will come. There's a concept of relative density. Otherwise, when the flotation இருக்கு. See, we are having an object with mass m. Mass m with acceleration to gravity g. So it's for a key actor minus mg. Okay, minus vdg. This is my buoyant force. Okay, so this technically it will give you your net force acting downwards. Okay, this net force we can consider it as some net mass into acceleration to gravity. Okay, and the net mass, if you divide it with volume of the object, you will get relative density. Okay, Paka. In general, what என்ன பண்றீனா, it's nothing but density of substance divided by density of water. This is your relative density. Okay, fine. அதை வந்து you could write it as weight of object normala divided by what is this? This is loss of weight by loss of weight. But இது வந்து ஒரு another form of whatever you've learned. This is, let's say this as a derivation of this normal basic thing, which is not required, because once you know the concept on spot you will be able to apply it. Okay, concept I'll try to strengthen it. Okay, no one is replying in the chat, guys, come on, it's so bad. I need some energy in chat to keep me motivated, please. No one's replying. Fine, Paka. Now flotation. There's three cases. Okay, when you have an object of super simple, I'll just make 3 boxes. Okay, this is my object number, box number 1. Idhila vande I'm having some fluid. It's having some fluid. Okay, some fluid. The fluid density is d. Okay, if I'm having an object of mass, this of density d1 nachiko, And there are three scenarios which you can observe. Okay, there are three scenarios which you can observe. This mass of d1. Okay, the first case is when your d1 is greater than d. When your d1 is greater than d, when the density of the object is greater than density of fluid, obviously it will sink. It will sink. So your object will be found here. Okay. Condition for flotation எப்படின்னு சொல்றேன். Okay, when you have an object whose thing is density d1 is equal to d, அப்போ வந்து it will be here. It will just sink. Okay, இந்த மாதிரி இந்த பொசிஷன் இருக்கும். அதே when you have the same thing, okay, when you have the same object, another density d1 is lesser than that of d, it will float proper. So this is my condition for floating. ஏன்னா why does this take place na? Because of this equation. நெட்டா வந்து I shouldn't have gravitational force acting downwards. After all that, I just get a high. Okay, hi Safura. So netta you should not have any force acting. If you have force na, it won't say float. Okay, that's all. Simple. Pakka. Thank you so much, Soumya. Okay. Okay, this is your flotation. I have a question for you. Okay, little interesting. A cubic block. Okay, there is a ideal fluid. I'll add a page here. There is a fluid. I mean, there's a block first. Let's say this block five centimeter cube volume. Okay, and let's say it's floating in mercury. This is my iron. So an iron block is placed in mercury and it's floating. Nice. Iron or density is 7.2 grams per centimeter cube. Mercury is 13.6 grams per centimeter cube. Okay, now what I'm supposed to find is the height of mercury okay, it can be height of block or height of mercury. Okay, height of block above mercury or height of mercury on the block. I can ask it two ways. Okay, simple. This is for one understanding question. This is a very, very, very simple question. Okay, this is my mercury, which is never blue. Okay. Okay, this is my iron. Okay, nice iron block. In the block when it's floating, the concept is okay. See, This is the volume of fluid displaced. Okay, and the volume of displaced fluid into density of mercury is what holding my entire iron block. Okay, volume of my iron block into density of my iron block. Easy. So volume of displaced mercury into 13.6 is equal to volume of iron is 5 centimeter cube into iron density is 7 point, what is 7.2 then? 7.2. So the volume displaced is equal to 5 into 7.2 divided by 13.6. Okay. So you'll get the volume displaced. Okay, fine. So with this you'll get the volume displaced. I don't want to calculate. It's so annoying. But there's one thing you should remember here. They have asked height. Okay, we know this is a cube for sure. And the cube there are 3 dimensions. One you're in the length, and then your breadth, and then your height. Here we are considering, we know that the cube breadth breadth is 5 centimeter. This is 5 centimeter. This is 5. This is 5, and this is 5. But if you consider in the cuboid, this is 5. This is 5, but this is not 5. This is the height we are supposed to find. Okay, so you can take volume as this of displaced fluid as 5 square into x in equals to 5 into 7.2 in divided by 13.6. So x will be equal to, just calculate it, you will get the answer. Okay, it should be around 5 5 20. It should be around 2.5 centimeter, around 2.5. Calculate it properly. Okay, so that's the concept behind this question. And now, okay, ideal fluid. It's a beautiful topic. Ideal fluid, you just have to know stuff. Okay, ideal fluid. So yeah. Okay, no one's replying. That was important question. Okay, so no one has any doubt. 2.8. Thank you. But if I calculate it now, it's coming around 2.65. But yeah, you're close. 2.35. But something. You get the answer. You get the idea, right? If you know how the concept works, it's fine. Okay, done. Paka. For the sake of mathematical uh, easiness, okay, we use something called as ideal everywhere. Ideal gas, ideal fluid, yeah, under ideal conditions. Sometimes we the questions are like, take G as 10. Ilana, it will be like, neglect air resistance, which can't be done. Okay, with all these stuffs, you can't ignore air resistance because it's present everywhere. Nothing is ideal. Okay, so basically ideal is something which is only theoretically possible. Okay, so ideal fluid in fluid mechanics is nothing but a fluid which is incompressible. Okay, the properties மட்டும் சொல்றேன், நீங்க நோட் தெரிஞ்சு வச்சுக்கோங்க. It's incompressible. Okay, fluid is incompressible. It's non-viscous. Homogeneous, and it should have no thermal conductivity. Okay, incompressible என்னன்னா when you press something la, when you press something, molecules come together. Molecules, when they come together, the density will increase, so there's a change in density. Viscous force I'll discuss. Homogeneous இருக்கணும்னா it should have the same substance throughout. So the physical property should not change throughout the thing. And then thermal conductivity இருக்கக்கூடாது, அவ்வளோதான். Okay, these are basically that's what ideal fluids are, but they don't really exist in real life. நான் ஏன் இந்த டாபிக்கை சேர்த்துறேன்னா, we have something called as equation of continuity, which is where what I want to discuss now. Okay, okay, something got into my eyes, guys. People, I hate Apple. இந்த மாதிரி மேலே மேலே போயிட்டு இருக்கு. Okay, equation of continuity, very simple topic. Okay, I'll finish it in like 5 minutes. Say you are having a fluid. Okay, or a fluid move ஆயிட்டு இருக்கு. It's based on the law of conservation of mass தான். Okay, when a fluid is flowing through a pipe வச்சுக்கோ, அந்த பைப்பில் வந்து there is varied areas of cross section. Okay, the varied area of cross section when the fluid moves, there will be different velocities. Okay, ஸோ இப்போ நீ பைப்பை நார்மலாக ஒரு கார் வாஷ் பண்ண டியூப்பில் வந்து வாட்டர் இஸ் ஃப்ளோயிங் அண்ட் இட்ஸ் கம்மிங் டவுன் போரிங். ஓகே, ஒரு சில டிஸ்டன்ஸுக்கு போகும், ஒரு சர்டன் velocity will come out. When you hold it and pressurize it and constrict the aperture, when you constrict the aperture, the velocity of water increases, right? Basically that's what equation of continuity is. But what it says now, rate of flow of mass of an ideal fluid is constant. Okay, this is basic stuff. Okay, which is what it says. Okay, it's எப்படி எக்ஸ்பிரஸ் பண்ணுறாங்கன்னா, m is constant. Okay, so let's say இந்த மாதிரி ஒரு ரெண்டு அபெர்ச்சர் இருக்கு. Okay, this is the cross section areas வேறு இடத்துல. This is how the fluid is flowing. Okay, say இங்கே வந்து இந்த area of cross section is A1, this is A2. இந்த area 1 cross section velocity is V1 வச்சுக்கோ. Density is constant, so density is D. இங்கே வந்து A2 V2 D. Okay, according to equation of continuity, A1 V1 D equals to A2 V2 D. A1 V1 equals to A2 V2. Paka. Clear? This is very simple thing. Okay, fine. So Technically, if you want to consider now, if a1 v1 equals a2 v2, we know that p1 v1 equals p2 v2 என்ன சொல்லுவோம்? pv is constant. Okay, fine. So we can say here that av is constant. Okay, area times velocity for every cross section is constant. Okay, பேங்கர் கான்செப்ட் இதுக்கப்புறம் இன்னொரு பேங்கர் கான்செப்ட் ஆர் பெர்னோலிஸ் தியரம். இட்ஸ் ஸோ லவ்லி. இது பேஸ் பண்ணி தான் வந்து யூஆர் ஏபிள் டு ஃப்ளை பிளேன்ஸ், ஏபிள் டு டூ அ லாட் ஆஃப் ஸ்டப்ஸ். ஓகே, டன் பக்கா. ஓகே கைஸ், பெர்னோலிஸ் தியரம். One minute. Okay. Lovely. It's basically conservation of energy. Law of conservation of energy தான். It's basically conservation of energy. What it says now, for a fluid flowing, an ideal fluid flowing, the pressure energy kinetic energy, potential energy, or a sum is constant. Okay, the sum is constant. Fine. Let's okay, இது வந்து no, thank you for the thumbs up. Only Safur is responding. Fine guys. Okay, let's இப்போ pressure energy ன்னு ஒரு புது டேர்ம் நான் கொண்டு வந்திருக்கேன். let's understand what pressure energy actually means. Then we'll get into Torricelli. இதுக்கு முன்னாடி we'll solve few questions based on the previous topic neither, and then we'll get into Torricelli and then surface tension அதோட முடிச்சுக்கலாம். Fine. So yeah, so pressure energy, so force into displacement is our work done. Okay, force is nothing but pressure into area. Displacement d is nothing but x of fluid. So basically pressure into volume is my pressure energy. Okay, pressure energy. Okay, PV, you would have studied this in a lot of in so many places. Okay, chemistry படிக்கலாம், physics you'll study again. Okay, fine, paka. No one's replying. Okay, never mind, I'll continue. This is your pressure energy. This pressure energy per unit volume. Okay, I forgot to tell you one thing. Pressure energy, kinetic energy and potential energy per unit volume. Okay, per unit volume is constant. Okay, basically law of conservation energy. So pressure energy per unit volume is nothing but your pressure. Yeah, so this is all your Bernoulli's theorems are about. Okay, so if you write Okay. இங்கே வந்து there is say இங்கே velocity is v வச்சுக்கோ. ஓகே, சே இது வந்து கிரவுண்ட் லெவல். ஓகே, ஸோ இங்கே மை velocity is v1, இங்கே v2, this is height h. For mass per unit volume, potential energy at this point will be taken as 0, plus my kinetic energy is half mv square divided by per volume, plus my pressure energy is p into v per unit volume. So my pressure energy is nothing but p, the point is take it as p1 will be equal to, in the point la it's mgh, it has risen by some height, divided by v potential energy plus half m v2 square by v plus p2. P2 is nothing but p1 plus h rho g minus h rho g. Okay. Okay, this is your equation inga. So you can cancel out pressure difference, which is so half rho v1 square plus h rho g is equal to rho gh plus half rho v2 square. But it's wrong, but still okay, it works. இங்கே வந்து it should have been p1, it's just p2. This is your Bernoulli's theorem. Okay, I'll solve some few questions. Okay. Okay. A U-tube, okay. This is not a U. This tube is accelerated with an acceleration of a. Sectional area வந்து a, small a, accelerated. There is a difference in levels of fluid. எவ்வளோன்னு கேட்குறாங்க. Simple. This YouTube example, okay, it's so bad the diagram, but still this is similar to this one. Okay, so when you accelerate, it creates an angle theta, and you know that angle tan of this angle theta is nothing but a naught by g, acceleration divided by g, and the height difference h2 by h1 by l is equal to a naught by g. So yeah, so technically இந்த மாதிரி question கேட்பாங்க. This is just a format of how questions could come. So இந்த மாதிரி இருக்கும்போது when is accelerated by this one a, in the height difference, difference divided by the length is equal to A by G. The G will be able to solve. Okay, fine. Let's keep this aside. ரெண்டு ஆர்ம் ஆஃப் ஹைட்ராலிக் ப்ரெஸ். ஓகே, ஒன்று வந்து 1 சென்டிமீட்டர் ஸ்கொயரில் இருக்குது, இன்னொன்று வந்து 10 சென்டிமீட்டர் ஸ்கொயரில் இருக்குது. ஓகே, ஃபோர்ஸ் ஆஃப் 5 நியூட்டன்ஸ் இஸ் அப்ளைட் ஆன் தி இங்கே 5 நியூட்டன்ஸ். இங்கே வந்து எவ்வளோ ஃபோர்ஸ் வந்து இது மேலே போகும். ஸோ தட் இந்த வாட்டர் ரிமைன்ஸ் இன் ஈக்குலிபிரியம். சிம்பிள். ப்ரெஷர் when exerted in ideal fluid, so 5 divided by 1 centimeter square, அதை மீட்டராக மாத்திரம்னா 1 into 10 power minus 4 will be equal to force divided by 10 into 10 power minus 4. So the force with which it can push up now is 15 newtons. Very simple. Okay, done. Thank you so much for your thumbs up, guys. Okay. Okay, there is an inverted U tube. நான் சொல்கிறது நல்லா கவனிச்சுக்கோங்க, because I haven't written questions here. There is a tube இப்படி இந்த மாதிரி இருக்கு. இந்த inverted U டியூப்ல இந்த பக்கம் there is இங்கே water, there is kerosene. வாட்டர் ஒரு லெவலுக்கும் கெரோசின் ஒரு லெவலுக்கும் ஹைட் இன்க்ரீஸ் ஆகுது. ஓகே, நவ் யூ ஹேவ் டு ஃபைண்ட் ஒருனோட ஹைட் கொடுத்துருக்காங்க. ஸோ வாட்டர் வந்து 10 சென்டிமீட்டர் ரைஸ் ஆகுதுன்னா கெரோசின் எவ்வளோ ரைஸ் ஆகிருக்கும்? நத்திங் பட் இந்த பாயிண்ட் த ப்ரெஷர் இஸ் சேம். பாஸ்கல்ஸ் லா. Okay, if the pressure is same at this point, then H rho G is constant. H rho G and the point is constant. Since rho is variable here, and then so this rho is height. We can say that 10 into water oda idu vandu 1 into G is equal to kerosene oda density 0.8 into H into G. G cancel. 100 divided by 8, 12.5 centimeter. This is the height at which kerosene is present. Okay, fine. Okay, water is flowing through a horizontal pipe of cross section here. Bernoulli theorem based பண்ணி horizontal pipe oda cross section, the rate of volume flow is 0.2 liters per second. Okay, ஒரு பாயிண்ட்ல அந்த ப்ரெஷர் அந்த இடத்துல ப்ரெஷர் இஸ் 30,000 pascals. Okay, fine. Where cross section is 0.5 into 10 power minus 4. Okay, where the pressure at a point where the area of cross section is 0. Where the area of cross section is 0.5 into 10 power minus 4 1 into 10 power minus 4 இருக்கும்போது ப்ரெஷர் என்னன்னு கேட்குறாங்க. புரிஞ்சா question? So basically you have water flowing through a horizontal pipe. Okay, அதோட area is variable. We know that velocity into area is constant. So nothing but volume is constant. Volume of water flow is constant. Okay, super. இப்போ இங்க velocity is nothing but velocity is nothing but 0.2 liters per second divided by 0.5 into 10 power minus 4 meter square, which is nothing but 10.5 centimeter square, because that's in centimeter cube. Liter வந்து I could write it as 1000 centimeter cube. Okay, so yeah, so this will be point, it will become, so let's say 2, so 400 1 paka clear, 400 centimeters per second. That one the velocity at cross section area of this. Okay, basically v1 a1 is nothing but velocity into area is nothing but volume per second. Okay, so equate panna you'll get this one. So 400 centimeter per second in one area, 400 should be ஒரு இடத்துல. Now considering energy change, okay, another point they're asking I should find the potential velocity in the position. It's nothing but 0.2 into 10 power minus 4 divided by 1 into 10 power minus 4, I mean 10 power plus 4, 10 power plus 3. Here it's 200 meters per second. Okay, so one point when the cross sectional area is 0.5 into 10 power minus 4, the velocity is 400 centimeter per second. When the cross sectional area is 1 into 10 power minus 4 centimeter square, the velocity is 200 meters per second. Okay, so இப்போ equate பண்ணோம்னா 30,000 plus half into rho is nothing but 1 inga, or 1000 into v square is 4 into 4 is equal to half into 1000 into 2 square plus. If you solve this, you will get 2000 inga, you will get 8000, 30,000 minus 2000. So pressure is equal to 36,000 pascals. Okay, Torricelli's law. Is there clear questions la? Okay. Based on Bernoulli's theorem தான் வந்து there is a lift and all, flight lift. Okay, Torricelli's theorem in short one liner சொல்லணும்னா say you have fluid filled up to some point. Up to some point, okay, this height h, and you puncture a hole somewhere. Okay, hole, and the இங்க வந்து water will flow out, and the water will have some velocity, and that velocity v is equal to root 2 g h. H is the height, above which till the water is present. Okay, very simple. And there's takeaway point வந்து என்னன்னா Torricelli theorem to have maximum range, okay, you should height from the ground, okay, of the punctured hole should be half of the total height of okay, let's not complicate it. Say I'm having a container, and the container if I'm poking it at h by 2 na, I'll have maximum range. Okay, this container is placed at the ground. Say this container is placed at height h, same. Okay, this is height h. For it to இதுவும் height h, water இருக்கு, இங்கே ஒரு ஹோல் போக் பண்ணால் வெலாசிட்டி இங்கே ரேஞ்ச் தான் மேக்ஸிமம் இருக்கும். ஸோ டெக்னிக்கலி பாதி ஹைட்டில் நான் வைக்கும்போது தான் வந்து பாதி ஹைட்லி இஃப் ஐ கீப் ஒன்லி ஐ வில் ஹேவ் ஹை வெலாசிட்டி, ஐ மீன் ஹையஸ்ட் ரேஞ்ச் பாசிபிள். அதுக்கு மேத்தமெட்டிக்கல் ஸ்டப்ஸ் ஆர் தேர், பட் ஸ்டில் ஐ வுட் ரெக்கமெண்ட் நாட் டு கோ ஸோ மச் டீப் இப்போ, பிகாஸ் ஐ ஹவ் ஸோ மச் டு கவர் இன்னும். ஓகே, I just add one more slide here. Basically, the other case is that when you have a thing here, and then this is your height h, and when height 2h irunchna 2h, appo for maximum range you should poke hole at in the point then you'll have maximum range. Oh my god, what happened? Is my screen visible, guys? Connect இருக்கு. ஓகே, பக்கா, சூப்பர். இப்போ தெரியுது. So basically this is what it is. Okay, I'll give you an example for Torricelli. See how I derived it now. When you have velocity, say one molecule of water is coming through this height, okay, basically this area is insignificant. So is the change in height here, so is the velocity here. Okay, fine. Okay, so there is only pressure difference, which is h rho g, which will be equal to my half into rho into v1 square. Okay, there is only pressure difference because you won't have any kinetic energy, because the kinetic energy is insignificantly small, and in the pakam you'll have atmospheric pressure, atmospheric pressure, so technically it's zero. The only thing you have extra is h rho g. Okay, so when you remove rho, it will be 2hg under root, which is equal to v. Okay, it's like a free fall from a point h. Okay, the velocity at point v will be at this point will be equal to root over 2hg. Okay, fine. So அதை பேஸ் பண்ணி so this is your h root over 2hg இருக்கணும். Okay, அதே வந்து if it was placed at some height h தான், if it were placed at some height h வச்சுக்கோ, அப்போ வந்து to have, see this is velocity, time taken will be equal to t is equal to v into displacement. So displacement is equal to v is equal to u plus a, v square is equal to a, v square equals to 2 into a into s. 2gh is equal to 2 into g into x. Okay, displacement. Okay, this is wrong. Which is yeah, time taken is equal to root 2h by g. Okay, this h is nothing but இந்த மேலே இருக்கிறது. Okay, the thing above, so which can also be written as this, taking this as capital H, the entire length, okay, and the distance from the ground as small h. Okay, this will be my t. So technically I want this thing. Okay, இது கிடைக்கணும்னா it's nothing but this minus this. That's what the questions are based on. Okay, so இப்போ வந்து உனக்கு இதில் displacement if you want to find it will be equal to root over simple 2 into h into h minus h. Okay, fine. Now this 2 into h minus h, இதை வந்து நான் maximize பண்ணும். To maximize this, இது எப்படி எழுதுவோம்னா, to எப்போ மேக்ஸிமைஸாக இருக்குன்னா when h minus h is equal to h by 2, அப்போ தான் வந்து my distance will be equal to the height at which, mean that horizontal displacement will be equal to the height at which it is placed. Simple. So அதில் இருந்தா I derive this one. I hope everyone understood. Okay, this is how Torricelli's law is derived. அதை பேஸ் பண்ணி இந்த ஃபார்ம் இருக்குல்ல, this formula பேஸ் பண்ணி தான் வந்து இந்த h by 2 வந்துச்சு, h by 2 கான்செப்ட் வந்துச்சு. Okay, this one. There is something called as Magnus effect. Okay, when you throw a ball, okay, when you throw a ball, spin பண்ணி விடும்போது, let's say it's spinning இந்த மாதிரி, okay, and it's moving இந்த மாதிரி. When it's moving like this, okay, air வந்து இந்த பக்கம் it acts with இப்படி, இந்த பக்கம் it acts with, okay, this is how air what a motion will be. Fine, let's denote it with red color. So air இப்படி இருக்கும், okay. இந்த பாயிண்ட்ல பார்த்தீங்கன்னா velocity of air is in this direction, velocity of ball is in this direction, means spin air. அதே வந்து if you see in this point, velocity of air and velocity of spin both are in same direction. Okay, so technically இங்க வந்து இந்த point of velocity will be equal to velocity of spin minus velocity of air. இங்க வந்து it's equal to velocity of spin plus velocity of air. Okay, fine. So when you have this thing going on, when the velocity இந்த மாதிரி இருக்கும்போது, okay, since we know that net energy is same, okay, ஆனால் இங்கே வந்து kinetic energy is less, இங்கே kinetic energy is more. So to compensate that, pressure energy here will be more, pressure energy will be here more, pressure energy இங்கே less, கம்மியாக இருக்கும். Because of which இங்கே pressure இப்படி ஆக்ட் ஆகும், இங்கே ப்ரெஷர் கம்மியாக இருக்கும், இங்கே ப்ரெஷர் வந்து கொஞ்சம் கம்மியாக ஆக்ட் ஆகும். ஸோ தட் தேர் இஸ் இந்த பால் வந்து இப்படி டிவேட் ஆகும். ஓகே, இன்ஸ்டெட் ஆஃப் கோயிங் ஸ்ட்ரெயிட் இட் கோஸ் கீழே இந்த மாதிரி. This is the reason why cricket balls எல்லாம் வந்து it will swingல, it's because of this thing. Okay, this is your Magnus effect. It's just a thing which you are supposed to know. Okay, I could solve a lot of questions, but still, yeah, there is a concept called as viscosity, but there's so many concepts, I can't take all of them at a time. But see, viscosity is simple. Okay, see, this is a river. These are river banks. Okay, river banks you have river water inga. When you observe, the water closest to the bank, okay, is almost stationary. And inga da vandu you'll have maximum velocity. Okay, because it's close, it'll be in contact with the wall, and it'll have almost zero velocity. Nee evlo bank kulla poriyo, the velocity increases gradually, and in the center you'll have maximum velocity. And again, if you go here, it'll decrease to go to zero. Fine, paka. Now the thing is, I don't have, okay, I can't explain Stokes lipo because okay, so no, okay, no one's responding, so it's fine. Bro, current electricity படிக்கணும்னா electric potential capacity படிச்சிருக்கணுமா? என்ன question bro இது? But it's not technically not the same thing, but yeah, you have to study. Okay, I'll give you an example. See, potential current electric potential is the one thing that causes current. Okay, potential difference தான் வந்து current cause பண்ணும். So when you skip potential, when you skip the cause of current, okay, the thing that causes current, okay, flow of electrons, அதோட அதே if you skip na, there is no point in just studying about the motion of electrons. Okay, for understanding, but you could, if you want to, but still I won't, it's not advisable. Okay, now let's say a layer pogum thanni. Okay, this is my stationary layer which is at 0. அதுக்கு மேல கொஞ்சம் ஃபாஸ்டா போகும் velocity, and நடுவுல it'll be maximum. Okay, இந்த நடுவுல velocity இருக்கு இல்லையா, this velocity இங்க வந்து say this is v1. Okay, this has some velocity v2. இதுக்கு if you see this portion இருக்கு இல்லையா, இது ரெண்டு லேயரும் வந்து they'll interact. Okay, this will pull it forward. Okay, this will pull it forward, whereas this will pull it backward. Okay, there is this tension, this is that mutual attraction thing. Layer it'll slide and go, but still there will be some attractive force which pull them together. Okay, say these are at a distance of del x. Okay, and the relative velocity between them, so v2 minus v1 is say del v. So there is a velocity gradient, del v by del x. Okay, this velocity gradient, okay, எவ்வளோக்கெவ்வளோ அதிகமாக இருக்கோ ஓகே அவ்வளோக்குள்ள there is force. ஸோ ஒரு சின்ன டிஸ்டன்ஸ்க்கு if there is more change in velocity, that means there is more interactive forces. That means, so my force is more. So I could write as F is proportional to del V by del X. And it's also dependent on the area of contact. Fine. So it can be written as F is proportional to area of contact. More contact இருந்துச்சுன்னா more it will move. More force will be there. Okay. I need more time to explain all this stuff. Okay. But still, so if you take force acting between those two layers of water, okay, F is proportional to A and proportional to del V by del X. Okay. So for viscous force is equal to, you have a proportionally constant eta into A into del V by del X. Okay, this is my viscous force, whereas eta is my coefficient of viscosity. Then you have Stokes' law. Okay, simple. Just imagine when you have something விழுகுதுன்னு வச்சுக்கோ, கீழே மேலேருந்து கீழே விழுகும்போது you will have mg acting downwards, okay, and you will have buoyant force acting upwards, and then you have viscous force as well. Fine. So the acceleration at which it goes will be equal to the net force. Our net force is nothing but my fmg minus my buoyant force, which act upward, minus my viscous force. Okay, fine. Okay, fine. Now just remember, for a viscous force acting on a sphere, okay, on a sphere is 6 pi eta r v. I don't have time to derive this, just remember. Okay, so when my sphere is falling, say a raindrop is falling down, அதில் வந்து mg கீழே ஆக்ட் ஆகும், and then you have buoyant force in air minus 4/3 pi r cube volume into density of air into g acting upwards, and also minus 6 pi eta rv. Okay, fine. These two forces, they act upwards, this force act downwards. Okay, fine. At one point, this is Stokes' law. This is what it says. Okay, the net force acting on will be equal to minus buoyant and minus viscous. There is something called as terminal velocity. So terminal velocity எப்படி work ஆகும்னா, when you have sufficient velocity அப்போ this entire thing will equal to 0, because see here we have velocity and 6 pi eta rv. Since velocity increases with acceleration at a certain point of time, mg is completely erased from the equation. Okay, you have no net weight acting downwards. Appo you'll have an object with a constant velocity falling down. Okay, that's your terminal velocity. If you solve this equation, you will get terminal velocity of an object to be 2/9 r square into mass of the object divided by eta into g. This is the velocity, terminal velocity, if you solve this equation for v. Okay, okay, simple. There's something called as laminar flow and turbulent flow, which is just a simple concept. Laminar flow வந்து you'll have 2 points, okay, say particles. The particles வந்து right Akhilesh, okay, you have two particles, okay. Say in a fluid which is flowing, இந்த ரெண்டு பார்ட்டிகள்லையும் when one precedes the other, okay, that's called as laminar flow. Okay, when one doesn't precede the exact same path of the other, it's called as turbulent flow. It's so simple, okay. But this is what I need to focus konjama, okay. இதுக்கப்புறம் we'll end the class. See, I'll take my time, okay. Okay, see here, just imagine you have water, okay. Again, same water, it's stationary. தண்ணி வந்து ஸ்டேஷ்னரியாக இருக்குங்க. This molecule of water is stationary, அதாவது it's having interaction everywhere and everything gets cancelled out, okay. It's stationary. But when you take the particles of water at the in the top, okay, in the surface level, when you observe them, they'll have force இப்படி, okay. They'll have force இங்க, they'll have interactive force இங்க, but they won't have forces in the in these places and all, okay. The same thing is applicable for the entire thing, okay. That's why they are stationary. But still, when they are stationary, there is a net force acting downwards. In the mari, there is always a pulling force, okay. When you consider this force on the entire spectrum of molecules, on the entire spectrum of possible interactions, there's a net pull in the mari, okay, in the mari pull that causes water in the surface level to act as a stretched membrane, okay. There is a force difference here, okay. It's being pulled in the mari, it's being pulled in the mari, it's being pulled in the mari. In the end one day it will be pulled just, okay, in the end it will be just pulled just in the mari mattum, not here, okay. Because of there is a net unbalanced force, okay, in the mari irukumbodhu it acts as a stretched membrane, okay. That's where the concept of surface tension comes. It's helpful in so many ways, but yeah, that's where the concept of surface tension comes, okay. Fine, that's where it comes. Now when you place a thin line, thin rod mari, okay, of length L on the surface, okay, it experiences a force of F, okay. And that force is acted upon at the two places. So in the mari vechikalam, this is the surface. If you take this as length of the rod na, force வந்து இப்படி act ஆகும் and இப்படி act ஆகும், F, okay. The force acting per unit length is called as surface tension. See, when you ஒரு ரப்பர் ஷீட் எடுத்துக்கோங்க, ஒரு கிளாத் எடுத்துக்கோங்க, சும்மா விட்டா ஒன்றும் இல்லை. If you pull it with some force na, it will act stiff, okay, like something you could balance something on it actually. இப்போ சும்மா விட்டுட்டிங்கன்னா it will fall off, okay. But when you stretch it with sufficient force, okay, the exact scenario here with some unbalanced sufficient force in the direction, it acts like a stretched membrane. That's why stuffs float on it, okay. When small insect la thaniyila poi nikka, the reason being surface tension, okay. Fine. Okay, when you consider surface tension for a rod vechukove, it has length L and force is acting rendu edathilum. So force divided by 2L is equal to my surface tension, because there is a length L in the pakkam, there's a length L in the pakkam. And then if you take a ring க்கு வந்து there's force inga, this is 2 pi r radius into 2 times inner circle and outer circle. Rend circle there is interaction with water molecule. So this is my length. So force divided by length is equal to my surface tension. Okay, same is applicable for everything. Paka. Okay. Okay, thank you Mono. Thumbs up. Okay. Okay, when you consider in the force circle, yeah, this force causing displacement, it comes under surface energy. Super simple. Okay, comes under your surface energy, which I didn't mention here, but see, super simple. Surface energy is when surface tension into the surface area. This is my surface energy. I'll explain you how. Okay, with this concept we'll and it because capillary reaction, okay, we have capillary reaction as well. Hmm. Say you're having a frame in the மாதிரி இந்த ஃப்ரேமில் you have a thin film, okay, and the film வந்து you have increasing the length by pulling it, okay, or bubble you have played with all the stuff, okay, you are increasing its area. You just consider நான் ரொம்ப accurate. See, when I'm pulling it, okay, இந்த மாதிரி pull பண்ணும்போது, okay, it increases with by a distance of x. I'm applying a force of F which is equal to the surface tension, and it is increasing with by a distance of x. Okay, force F L. Surface tension is equal to F by L, okay, because one side of the film, okay. So S into 2L. Will do my work done. This work done to increase its area is called as my surface energy. So I've done some work. Okay, just imagine there is a thin film of say soap, okay, அதை வந்து நான் pull பண்ணுறேன். When I'm pulling it, I'm applying a force of F. this F force is equal to the surface tension of that substance, okay? And the force F over length L is increasing the area X, okay? So my surface energy, so I'm doing some work. That work done is nothing but my surface energy. So the amount of work I'm doing, it gets stored as surface potential energy. Okay. Okay. Done. Paka. Okay, done. So it's nothing but surface tension times area. Usually that's how it works, okay? So when they ask you questions from how இப்போ வந்து ஒரு ட்ராப் இருக்கு வாட்டர் ட்ராப்லெட் இருக்குன்னு வச்சுக்கோ, அதோட ரேடியஸை ஃப்ரம் R1 to R2 இன்க்ரீஸ் பண்ணும்போது how much energy is requiredனா it's nothing but change in area, change in surface area for a bubble இருந்தால் 2 times of its area because outside and inside. If it's a solid thing, 1 time of its area, change in area into its surface tension. That's your work done, okay? Basically this work done is equal to surface tension into change in area. If it were droplets na, they are solid, so they have surface வெளியே மட்டும். So when they fuse coalesce together, energy dissipated is nothing but their surface tension times the amount of area which has increased, which has decreased, okay, something 4 pi r1 square plus r2 square. அதை வந்து வால்யூமோட சப்ஸ்டியூட் பண்ணி you will get something. Oh, someone's calling. That's your basically that's your work done, okay? Fine. Then you have something called as excess pressure. I'll be in a minute, 1 minute, okay? Somebody just rang the bell and left, okay? There is something called as excess pressure, which is super simple, okay? Nothing. There is one illa. But this is important in the concept of work. How now overall சொல்லியிருக்கேன். Just try to remember, okay? Fine. There is a concept of excess pressure, okay? Yeah. Basically the pressure, excess pressure is nothing but force per pressure is nothing but force per area, okay? Just try to remember it. Excess pressure is written as 2s by r. இது எப்படி வந்துச்சுன்னா it has a huge derivation, but in this crash course I don't think it's required. கொஞ்சம் complicated derivation. If I had time I would have done it. இப்போ இல்லை. So yeah, this is my excess pressure. Basically the thing is, when I have a bubble and increase its radius from R1 to R2, okay, when I increase the radius, okay, surface energy increase ஆகும், okay? When the surface energy is increased, okay, the energy is increased. Surface energy is nothing but energy per unit area. So when it is increased, the increase is done by some excess pressure inside. Fine. So pressure into change in volume equals to the energy done, okay? And the change in energy is nothing but say 4 pi r square plus 4 pi r square, which will be like, okay, it's better I derive it. Okay, fine. Say I have a bubble. I have its radius is r. Radius r one, it's increasing by dr. Let's go. Okay. Change in area is not equal to 4 pi r square r plus dr whole square minus 4 pi r square. Fine. So change in area is equal to 4 pi r square plus 4 pi dr square minus 4 pi r square plus 8 pi r dr. Okay, fine. Now dr is so small, so dr square is also small, negligible, cut. 4 pi r square minus 4 pi r square, done, cut. So my change in area will be equal to 8 pi r dr. Okay, this is my change in area. So this change in area times the surface tension is equal to dA into S is equal to my surface energy into is equal to work done. Change in area is 8 pi r dr into S is equal to my work done. Fine. Fine. This is clear. This is how I'm deriving stuff. If you understand, it's fine. Okay. So we have found that work done is equal to either. Now this work done is equal to change in pressure, the excess pressure we are finding. Okay, excess pressure is the pressure which inside நான் எவ்வளோ கொடுத்தேன் எக்ஸ்ட்ராவா. Okay, when I'm blowing a bubble, say அப்போ வந்து I'm adding some pressure for which there is an increase in area over a distance. Okay, so it initial area is 4 pi r square. Now it's force, so pressure is nothing but force per area. Now force into area I'm having, pressure into area is nothing but force. Now this force is acted over a distance of dr. Or a distance dr. Okay, fine. Or a distance dr acted. It causes it to, this is the energy, this is the work done by the excess pressure, which is equal to what we found here, 8 pi r dr into S. Fine. 4 pi r square dr. We have r here. Cancel. So my excess pressure P is equal to 2S by R. This is how we get excess pressure formula. Okay, fine. Basically, it's nothing but I'm giving some extra pressure because of which it's expanding. Okay, fine. Are they able to expand? Because there is some pressure acting on some area, which is force. It creates some displacement, which is work, and the work is equal to change in surface energy. Okay, we're equating both and we are finding this one. Okay, clear. Okay, all right. So yeah, so only one thumbs up. Come on, guys. Only Suffer is responding. Basically capillary action is கொஞ்சம் too much for you. Neat level they won't ask much, but I'll still give you an idea, basic idea of how this entire thing works. Okay, wow. Okay, one more thumbs up, thank you so much. So basically capillary action is simple. Okay, simple. When you consider it, okay, super simple. Okay, just consider you have a tube. Okay, or a test tube. Okay, அதை வந்து you're dipping it in a tube, you're dipping it in a liquid. Okay, or you're adding a liquid something. Basically when you have something, some substance inside a container of another substance. Okay, this is, say this is my steel, and say this is my water. Okay, or some other substance. When you have that substance inside, okay, either it can form a convex shape. Okay, it can stay straight, or it'll form a convex shape. Okay, concave, straight, flat, or convex. Okay, this is what it happens. So it will form a convex, it can be a flat line, or it will be a concave. Okay, why concave adana? See here, the substance இருக்கு இல்லையா, the substance, when there are two types of forces. Okay, there are adhesive forces and cohesive forces. Fine. Okay, so when there is interaction between the உள்ள இருக்க சப்ஸ்டன்ஸும் அந்த கண்டெய்னரும் அதிகமாக இருந்துச்சுன்னா, okay, when the attraction between molecules of one thing and the molecules of other thing is more, it will form concave. When the attraction is similar to that of the other, it will stay flat. When the attraction is comparatively lesser to that of the other, it will form convex shape. Is it clear? There isn't much to talk about, but yeah, this is what basics of capillary reaction is. Okay, okay, I think Manu understood. Manu, thank you so much, Manu. Okay, yeah, this is the entire. Yeah, Safuraz, one more thumbs up. Thank you so much. Okay, when the interaction is convex, okay, I'm having so much cold. I have to use this in here, adikadi. Um, when there is interaction is more, okay, the level of fluid rises. Okay, I'll show you an image. Okay, this is what basically happens. Okay, um, when you place the liquid inside, okay, it will increase its length, it will rise up. Okay, when it rises up, okay, usually when the எப்போ rise ஆகும்னா, when the interaction between, say, this container and the liquid is more. அப்போ அது அந்த மாதிரி ரைஸ் ஆகும்போது it will form convex shape. Because I'm not able to draw properly, it will form a convex shape இங்க. Okay, it will form a convex shape and it will rise because the interaction is more. Okay, paka. If you see here, இங்கே பார்த்தீங்கன்னா when it dips it forms a concave shape, okay, because the interaction between its own molecules is more than that of this, அதனால் it forms convex shape. அதே இங்கே வந்து the interaction is more, so it rises up and forms a convex shape, okay. These capillary tubes are like super thin, okay. அதில் தான் இந்த if you get into MBBS na you will use it in to find clotting time and all, okay. Fibrin thread former or he will be through it, the capillary tube you will be cutting it, I mean breaking it in half, okay. So yeah, basically this is what capillary action is, okay. So now the key takeaway is they usually ask excess pressure inga, okay, but it's not required usually for NEET level, so I think I'll skip it, because when you have excess pressure, because of excess pressure தான் வந்து this entire thing happens, okay. When you have convex shape na, when you have convex இருக்கும்போது you'll have some excess pressure here, atmospheric pressure plus some excess pressure, okay. Okay, it's fine, I'll tell you basic stuff. In the equation order we'll finish the class, okay. When you have a tube and when it forms a convex shape, okay, as I told you, when it's supposed to form, okay, when it is supposed to form a convex, it'll have some excess pressure, okay, fine. So வெளியே இருக்க லிக்விட் வந்து ஒரு ஹையர் லெவலில் இருக்கும், உள்ளே இருக்க லிக்விட் இட் will dip down, okay. See, this is height h. You'll have P naught, which is atmospheric pressure P naught, and your excess pressure P, okay, fine. Now we know pressure equate பண்ணும், so in the level it will be same because of Pascal's law, okay. P naught plus P is equal to Pascal's law body, it's P naught again here plus H rho G, okay. So P naught cancel, P is equal to H rho G. P is my excess pressure, okay. This excess pressure I can write it as 2S by H equals to H rho G, fine. Two S by R actually, 2S by R, 2S by R then, because the radius of thing, yeah, 2S by R. So H can be written as 2S by R rho G, okay. Paka. Let's understand why it's cos theta. Sometimes it's written as cos theta, because if you see interaction வந்து it'll be in the mari. Theta is this angle, okay. This angle interaction இப்படி இருக்கும், okay. It's either இப்படி and இப்படி இருக்கிறது it's sign of your surface tension, and இப்படி இருக்கிறது தான் வந்து உன்னோட cos of surface tension. So cos தான் வந்து உன்னோட கீழே இருக்குது, so we instead of writing 2s we write it as 2s cos theta, because cos theta தான் வந்து it's pulling it downwards, okay. So இந்த மாதிரி you find the height எவ்வளோ டிப் ஆயிருக்கு or height எவ்வளோ increase ஆயிருக்கு using this thing, okay. Same thing if you want to write it for convex na, it will be in the exact opposite way, okay. So I hope you guys got what I was trying to tell here. இதோட the chapter is over. இதெல்லாம் வந்து they won't usually ask a NEET examination, but still I wanted to teach you guys, because let's stay prepared for whatever it comes, because exam 2025 பார்த்தீங்கன்னா it was super difficult. 2026 அதிகமாக கேட்டாங்கன்னா yeah, so அதனால் படிச்சு வச்சுக்கோங்க. So இதோட we'll finish the class, and thank you so much for everyone joining the class. Around 400 members have watched this lecture. Thank you, Safura. Constant you're texting in the live chat, okay. Okay, throughout the lecture you had a good energy. And Mano and Dharun and Merlin and so many people. Thank you so much. With this hostel in time வந்து 10 மணி இப்போ 10 10 20 30 ஆயிடுச்சு போய் திட்டு வாங்கணும். Okay guys, bye bye, see you, thank you so much.